Hello everyone, welcome back to Ask a Scientist Gaming, where we combine mediocre gameplay with expert science. I'm Ken Hansen, Associate Professor in the Department of Chemistry and Biochemistry at Florida State University. I do all things light matter interaction, photons driving chemical processes, but more importantly, joining me today is Dr. Billy Oates. Billy, if you wouldn't mind introducing yourself.
Yeah, first, Ken, thanks for having me. Looking forward to this. Maybe not the video game playing, but definitely happy to be here. So Billy Oates, I've been at Florida State, FAMU as a Joint College of Engineering for about 15, 16 years. My background, solid mechanics, smart materials, fracture, uncertainty quantification, quantum computing. I basically have ADD in research. So I also work with Ken on some light matter interactions in polymer. So glad to be here. Looking forward to it.
All right. Equally important, what game are we starting with?
I think we're starting with R.B.I. baseball.
R.B.I. baseball. There it is. All right. So this is presumably near and dear to your heart.
Yeah, I thought I was going to get drafted by the Braves.
Yeah,
Ended up having to find another job.
Yeah. Professor was plan B. Yeah, you were still into baseball. I mean, you coached your kids.
Yeah, coached my kids. I think we finally ended that. My son just graduated high school. I think he's going to call it quits, baseball. But yeah, it's been fun.
Wait, that's your youngest graduated high school?
My oldest.
Okay, the baseball player.
The youngest is into soccer, so we still got a few seasons to go.
So do you feel like R.B.I. baseball influenced your coaching?
It definitely made a difference, as close as I was going to get to the major leagues.
Now, I will say I learned the rules of soccer from playing FIFA soccer on Sega Genesis.
Oh, yes?
Yeah?
Maybe I should do that, because I still don't understand offsides.
So you're not a hockey player either.
No. Grew up in South Georgia.
Yeah.
I don't think I've ever held a hockey stick.
So I knew offsides from hockey, and it turns out it translates directly to soccer. So.
Okay. Something about you can't go past the ball on transition. But I don't know. Out at Forest Meadows, I don't know if the refs are consistent. That makes it even more confusing.
That's you're learning via that pathway. Like it. Sort of translates. No, Scuzba, you're right. So in hockey, they have the blue line. The blue line dictates offsides, which is basically, if you have the puck, you have to be the first one to cross the blue line. Otherwise, you're offside. So nobody's in the zone before you. In soccer, it's dictated by the furthest back player. But I think it's the same rule. You can't. I guess considered sort of a moving blue line is what Scuzba said. So yeah, I think that's a fair take. So is it coming back? Does it feel like instincts are...
Yeah, I mean, I was hitting all those home runs before we started.
So most of my guests...
There we go. Speaking of that, I didn't think that was going to carry.
It's well done. All right. So Billy settled in. If you guys have any questions for Dr. Billy Oates, he does mechanical engineering, smart materials, fractal analysis of data, uncertainty analysis.
Who knows who's online, but I used to work in industry too. I used to make airbag inflators.
Really? I did not know that.
Some company called Takata. I don't know if you've heard of them.
No. Well, the cycle company, yeah.
Well, no, this company was in the news. I was going to teach one of my finite element classes one morning. I saw in the New York Times this company was this major recall. I was like, oh, let me check the timing on this. It was due to some airbag inflators that were been designed shortly after I left. So basically they change it. Well, if you're not familiar with these, they use solid propellant. So it's like a controlled pipe bomb.
Yeah.
Inflate the bag. And you got to make these pellets just right with the right pill size. Otherwise, it'll like turn into gunpowder. And they started changing this, and they started seeing these things in Florida because humidity started interacting
discharging
with these things.
Holy shit.
Well, it degraded the pellets, and they had some pretty bad situations. Those things turned to shrapnel.
I mean, those airbags are crazy because you basically take a chemical species it's highly reactive once you ignite it or initiate it, and then it generates gas really, really quickly.
Yeah.
And that's how you fill the bag. And it's usually like an azide or something that makes nitrogen gas or something like that. And one thing to note is I think it makes a byproduct of the early ones was like sodium hydroxide or something.
Yeah, I think some of ours was using that early on, but it gave off too much NOx and carbon dioxide.
Yeah.
And we thought, saving your life, it's not that big a deal. But they went to a new propellant, and it was harder to ignite.
I see.
And we'd have to do these tests for DOT and the German version BAM. And if you're carrying these in a like an 18-wheeler on the interstate and it catches on fire, you want these things to go off properly. And so they put these on. They would basically take a pallet, fill it with put some diesel fuel on it, and then throw the inflators on it and light it and see what happens. And so with the new propellant that was hard to ignite, they had put this big initiator on it to get the reaction going. And it would sound like the whole thing goes off and this initiator goes off. So they're doing this experiment, and this is back in 98, I think. So this is Bernuri.com, and it was hard to find a lot of good technical people in the lab. So you have all sorts of maybe not the most well-trained folks working there.
See what happens.
It's like, hey, watch this. And so they were doing a test out back. It's in a little like closet that has cinder blocks around it and a little window. They do the test. They hear this explosion, and you have to wait like 5-10 minutes, make sure nothing else goes off. So he thought the whole thing went off. So he waits 10 minutes and then walks around and he pokes it with his stick, and that's when the rest of it went off. He was okay. He had like a piece of shrapnel in his stomach they had to take care of. But
I mean, eardrums had to be.
Yeah, because we were having a meeting upstairs and we heard the whole building shake. It's like, wow, that was a big one.
Wow.
So it was kind of crazy. I got to work with a lot of cool rocket scientists, but just blowing stuff up all day. That part was fun to some degree. But the place that they made the propellant, it was this place out in Moses Lake, Washington, and the way these are made, and maybe you may know more about this in chemistry, but it looked like some of these pharmaceutical instruments where it's probably a room this size and you had a big pill making machine.
Yeah.
So you put the powder in the center, it would come out, and there was these like metal dies that would press and make the pills. And anytime you're pressing something, compacting it can get a little hot. And so the door that comes into this room, it's a big freezer door. And so they said one time the thing overheated and ignited the whole room. They said what happened was that freezer door first sucked in when it burned all the oxygen and then blew it out in the hall. I mean, they were lucky the whole building just didn't go up.
Yeah.
It was at least contained.
I mean, so one of our canned questions we usually have is, what's the worst accident you've seen in the lab? Are those, you captured those two? Are those those the big ones?
I can't think of that's probably the best one I can think of.
So At some point when I get good at video editing, I want to compile all the accidents that happen together. Because like Angela Knapp, a marine biologist, hers is a shark attack.
Really?
Yeah, you contrast that with exploding reaction chambers and
Was that here at FSU?
No, that was before she was at FSU.
Okay.
But I mean, they go international waters. And, yeah,
Man.
it's crazy. All right, Reese's Pieces wants to know, how do you define fractal? What characteristic do you think is necessary to say that's a fractal?
Yeah, so as an engineer, I kind of use a loose description. So, there's many of these in nature, like broccoli is a good example, leaves, pretty good example.
Your lungs?
Yeah, your lungs is another good one.
Yeah.
So, and maybe if you think of, at least in Florida, some of these trees, the large trees we have here. And so the idea is if you look at a tree from kind of far away, you see all these branch structures. But then if you zoom in to like maybe one branch, then it has smaller branches that branch off. And so it looks the same whether you start to zoom in or you're farther away. So that's basically what a fractal is. As you zoom into these different length scales, the geometry looks the same. You could have this in time as well. And there's a guy at the Army that I talk to frequently that's done a lot of nice work in this area, and more in biology. And he had this interesting paper on cerebral blood flow. So they found that you can measure the blood flow through the brain, and you can look at the pulses between each heartbeat, and then you can compare those and look at how they're distributed. So if your heartbeat is regular, it's going to be the same thing every time, or it could have some randomness to it, or it could be perfectly random. It turns out it's usually not. It's somewhere in between, and that is a fractal. Sometimes you feel like your heart may skip a beat, so that's a really long one. Sometimes it may beat rapidly. The interesting thing in this paper was some people had a single fractal or close to it for their cerebral blood flow, and then others had what they called a multifractal, which is basically a fractal that's distributed about. How did I miss that? A multifractal is just a randomly distributed fractal, so it's not perfectly one. What's interesting is the people that had a single fractal or near single suffered migraines, and if it was a multifractal, they didn't really suffer migraines much. The thought was that if you're under different stress, you can adjust and still function without getting headaches. The thought is, well, if it's a multifractal, then you have this ability to adjust, to different stress environments. So it comes up everywhere. We've mainly used it for materials research. The thing that's interesting in at least the things we've been doing is if you come back to say just the idea if you can keep zooming in, and actually if you check this later, if you just Google zoom fractal, there are people that have simulated these and put up zoom videos that last like 12 hours. So the idea is if you can keep zooming in that far, then you have these infinities of dimension, and infinity is really hard to compute as an engineer. But if you use special math functions, which is basically a power law, you can get around it. And so then we can simulate a lot of these things that would otherwise be impossible to simulate. So we're trying to do that with some work with Ken on these complex quantum dot distributions and photochemical pathways to build some crazy artificial muscle.
So what I love about working with Billy is, so you're a mathematician slash mechanical engineer, right? You did a postdoc.
Yeah, postdoc in math.
Yeah. But like when Billy and I are working on these photomechanical polymers, it was several years ago now, but you're like, I saw this interesting paper about fractals. I'm going to look into it.
Let's try it.
And then from then on, it's like everything can be fit with a fractal. Like Billy found a hammer and there's nails everywhere.
I try to at least find big hammers.
Universal hammers.
Yeah. I mean, at least the uncertainty quantification, tell me a problem that has zero uncertainty. So I figured, yeah, that's probably something I should learn.
Yeah. A real problem? No. Well, it's fun. It's surprising how much it works. And like your discussion with like Sachin regarding polynomial fitting versus fractal, like there are things that uniquely can be fit or must be fit with fractals.
Yeah, I mean, you could, I guess, use just well, actually, I thought about that more after he mentioned that. And, if you have a system that's truly fractal, then you can't compute it with integers because you'd need an infinite number of terms. So, yeah, in those kind of situations, it is really useful.
Yeah, so Reese's Pieces had a follow-up. I tend to think of fractal as behaving like fractional dimensional objects, like between 1 and 2 or between 2 and 3.
Yeah.
Which is what you alluded to there.
It's dead on. Yeah, if you take a 2D box, then you draw a line in it, and then if you break that line up, crap. You bend that line around, it's going to try to fill up that two-dimensional space. But it's not going to perfectly do it. So
just threw to an empty first base there. Unforced error, ladies and gentlemen.
It's definitely not a neural network back in '88.
Machine learning NES, get on that.
But yeah, you break up these lines and they'll fill part of the 2D space, but not completely. So it's kind of like a dimension that's not perfectly one because it's filling up the 2D space, but it doesn't fill everything.
All right, Tribal Luminescence wants to know, is there fractal music? And there's a follow-up by Reese's Pieces. Yes, I'm reading a few papers on fractional distributions for a Bach fugue.
I think so, and I'm certainly not the expert in that area, but I've heard if you think of a dripping faucet, if you're trying to sleep at night, if it's dripping exactly like every second, becomes monotonous and you kind of ignore it. If it's dropping randomly, it's like Gaussian noise. I think some people use that to go to sleep. But if it's a fractal, meaning you have a drop and then you keep waiting, it's like, all right, is it gonna drop? Is it gonna drop? Yeah, and so I think that anticipation of this fractal for some reason keeps people engaged.
Huh.
And so there may be something about music. Man, I gotta switch out my pitcher.
Yeah, you're getting wrecked right now. Yeah. 12-2. Oh, yeah, game over.
You can tell I can't multitask.
Yeah. No, you were crushing it earlier before we
Thanks for that, Ken.
It's hard to do both at once. Tribal Luminescence actually is one of our colleagues. He can attest to that. But, so do you want to guess what this... I looked up the speed run in this game was. So the fastest somebody has won a single game in R.B.I. baseball. What's your guess?
A whole game?
Yep.
Can they do... do they have to play the whole thing, or can you win?
There's a 10-run rule, yep.
There's a 10-run rule?
Yep.
It's like 5 or 7 innings? Oh, gosh.
I think it's just 10-run rule, any inning.
Yeah, okay. Oh, so if it's any inning,
yep.
Then, I don't know, 5-10 minutes?
So the record is 2 minutes and 43 seconds. And so they did exactly that. They scored 10 runs almost immediately. And then they just got them out. That was it. The end of the inning. Game over. Okay. Yeah, speedrunning is one of my favorite hobbies because, like, the scientist in me just loves it. 'Cause it is just figure out the rules and how to exploit them. Apply some fractal math to R.B.I. baseball. Deconstruct the games. There's also a speedrun category for the fastest loss. Takes a little more time, actually. Like 3 minutes. Fractal music. I mean, it's going to show up everywhere. It's a natural...
Yeah, I think, Gaussian systems or perfectly ordered systems are not the norm. Everything else in between is fractal.
What's fun, what I love about modeling and fitting data is, mathematicians did this fractal math like hundreds of years ago.
I know.
And then all of a sudden, engineering latches onto it. Eventually it'll infiltrate chemistry. And then it'll go higher up the abstraction level. Sociologists will use it at some point.
Yeah, so I guess one of the things I hadn't talked about is there's this distinction between fractal geometry and fractional or fractal calculus. We use calculus to try to predict a lot of these things from changes of rate. And figuring out how to take these derivatives is interesting. So I can't remember how many years ago, but I had no idea what this was. And one of my colleagues in math at FSU, Yusuf Husseini, he was telling me about looking at viscoelasticity in polymers. And he said, when I do this, I think, if you think in terms of, I'm like my dad was a diesel mechanic and I'm a car guy. So there's your dampers on your car. Forces depend on the velocity that the car's moving. And that I use the same thing to model complex viscoelasticity. And that's where I need infinite number of parameters.
Yeah.
So my friend in math, he told me several years ago, he's like, Billy, why don't you just use a fractional derivative? It's like, a what? How can I take a half a derivative? Calculus was hard enough already. And so there was a way to do this. And I thought of it when you mentioned mathematicians figured this out a long time ago. I think it was Leibniz that figured this out like 100 years ago. I think maybe, I can't remember who he was asking this. But it never took on at the time. It was hard to compute. It's an integral. So you need a lot of, either you could do it for a few simple functions or, you needed a computer. But since then, it's taken hold. We got better computers to do it now.
Yeah. I mean, that was probably one of the fundamental limitations, right? Because if you want to fit data, it's very different than deriving the equations. Yeah. So are you in New York again?
I think so. I think I was San Francisco last time.
Yeah. Oh, okay. You were San Francisco. I apologize.
Or maybe that was pre-live.
No worries. Because you're fielding now, right?
Yeah.
Yeah. So you're in New York this time. And I think they're the American League All-Stars. Isn't that what AM is?
I think so. And I started out hot, but man, they're really hitting the ball.
Nice.
All right. Got a force now.
I won't watch baseball, just straight games, but I do watch highlight reels on YouTube. It summarizes just, peak plays.
Yeah, I can't watch a full game unless,
Your kids playing.
Yeah, or, if I'm going with family or friends. It's not a spectator sport like football or soccer.
I mean, even in person, you're there for the ambiance and the experience, but watching on TV,
So it's funny, when I was playing, I could do that because I could just relate.
Yeah.
And I think when I was in college, there was some studies someone was doing with monkeys, and they were just studying their behavior or whatever when each of them were like eating bananas or something. But then one of the grad students started eating a banana and the monkeys just stopped and started watching them. So I guess, man, they can relate to that. And I was like, man, I'm a monkey. I play ball. I can relate to these folks more and pass it on. So
that's awesome. That's most of our audience. They're mediocre game players. They love watching. They can relate to it. Oh, that's amazing. Speaking of baseball, so the Moneyball phenomenon. Have you seen the movie? Have you read into this? Is this something that intrigued you?
Yeah.
It's just data analysis, right?
Yeah, I definitely watched that. That has been fascinating.
Yeah.
Just finding that right metric.
Yeah. Well, what they need is fractal analysis of baseball.
Yeah, okay, so funny story. So I teach a Bayesian uncertainty class. I taught that this past semester, and it's kind of a hard class to have exams in. So we do some homework and we let the students do a project. Some student come up with a project that they were gonna try to predict NBA scores, and they use Bayesian analysis for this. And so they basically come up with a model, and they had some metrics on what they thought would end up predicting the score, or at least who's going to win. And it was, I think, about 60% accurate.
Huh.
And he said, according to like Vegas odds, that's pretty good for a model.
That is an amazing metric to assess the model. Like Vegas, how much money in return you get. Like it's a very quantifiable thing.
Yeah, so he went through and, you got these fitting parameters you got to put in there.
Yeah.
He did the uncertainty on the parameters and ended up figuring out he had a decent model. So it made me think, I need to do this for baseball.
I mean, I love that scene in Moneyball where it was just like he gets on base. That is the metric. That's what we care about.
And
that translates.
I don't use machine learning for material science, but the folks I talk to, it seems like it always comes down to, okay, well, what's the material descriptor you're going to use? What are you going to put into this neural network to try to predict behavior or whatever? So just coming up with what those are. Maybe you just got to get a neural network to figure out what those are first.
Yeah. And that's when we had Chris Mills on to talk about machine learning and AI. The data sets, and if they're intrinsically biased or there's problematic aspects of the data set. Garbage in, garbage out.
I guess, some will use these what's it called? Unsupervised learning. So then, to just clump it into whatever it thinks is appropriate. I just makes me really uncomfortable when I'm designing an airplane that my mom is going to be on.
Yeah.
Right? You don't know why it's come up with this. Pretty scary.
Yeah. And to be fair, that was early aviation in human brains, right? Just like, I think this will work.
That is true.
I mean, we've gotten better since then, but yeah. All right. Tribal Luminescence has a fun technical question. What's the difference between Bayesian and frequentist uncertainty?
Yeah.
So for the non-expert audience, what are Bayesian and frequentist uncertainty? What's the difference?
Yeah, that's a good one. I should know it since I told you I teach that class. But let me see if I can explain it why I'm making this out.
And while drinking beer.
Yeah. So frequentist statistics is more the standard statistics you learn in high school or maybe most college, at least undergrad classes. And so it uses things like mean, standard deviation, typically assumes central limit theorem, basically meaning that you have quite a bit of data and you can trust that that data is sufficient to describe the statistics of the problem. When you're building a model and looking at the statistics, it's deterministic. So the parameters in it are fixed parameters. And I'd say probably that would be the best description between the two. So frequentist statistics has parameters in it that are fixed. Bayesian statistics, on the other hand, parameters are random. So they have some randomness associated with it. And that randomness can be quantified through the fact that you don't have infinite data. You may have a very small amount of data, and so it'll accommodate any size data set. And there's this great book called The Theory That Would Not Die, which kind of gives a historical view on how this Bayes equation on the Bayesian statistics side started by this clergyman, Thomas Bayes. The story goes it was found in his attic after he passed away, and then it almost died then, and it kept coming back. It was used to figure out celestial mechanics. It was later used during World War II. They cracked the Enigma code. It was Alan Turing. Yeah. There's a part. Do you remember the name of that movie that came out not too long ago? The Imitation Game? Is that it?
Imitation Game, yep.
Yeah, so I kept waiting to see, okay, where is he going to show Bayes' equation in the movie?
It needs to be there. That's your moment.
And so there's a part in the movie where they're struggling, they're trying to figure this out because they'll change the Enigma code, the keys on the typewriter every day. So you only have a day to crank through this mechanical computer to figure it out, and then you got to start over. And so Turing, according to the movie anyway, Turing was in a bar that night, and he realized every morning they start the day by saying Heil Hitler. And so he used that as a way to, continue training and using data until they figured it out. But I think in terms of how powerful it is, one of the later descriptions in the movie, or not in the movie, but in the book, was when, say if you're working at some government agency, those 3-letter words, and a politician comes to you and they're asking about nuclear warheads and the safety of these. If you're a frequentist statistician and you want to know how safe these nuclear warheads are, if someone accidentally drops one, they're like, oh, just go drop a bunch of them and see if any explode.
You get a distribution.
Yeah.
Fine.
Yeah. If you're a Bayesian statistician, you may say, okay, well, let's look at travel logs, let's look at maintenance, let's look at the psychology of these people that are managing this, and see if we can infer some things. So that's always a good one.
I mean, that's interesting. That alludes to like insurance companies. It's like risk analysis, right? That's
what is it? These actuarians,
Yeah.
they probably use some of this stuff to try to sort that out.
To decide whether they should recall this car that's going to kill X percent of people.
Yeah. I mean, the other great one is, some folks that are doing experimental drugs. Say if it's some experimental drug for cancer treatment for kids, and you get halfway through this thing and realize, okay, this drug is helpful, let's stop this placebo and use it in those cases. Or if you just want to bet on NBA games, build your model and do a little side cash.
Man, I really hope that student used that at some point for betting or something.
I hope so.
I mean, they could blackball you for that, right? Like, counting cards it's not illegal. They can just stop you from entering the casino.
Yeah, I mean, I hang out in our Amy Help Center talking to students. There was a few students like, oh man, I was debating on taking your class. And I was like, yeah, you missed out, man. But as we were talking about it, there's like the online betting apps.
Yeah.
I forget the name of them, but it sounds like you can't do it in Florida.
Oh, really? I didn't know that.
Yeah, I don't know if it's like Indian casino lobby or whatever, but yeah, so that kind of threw a wrench in my plans.
One of the reasons not to live in Florida. All right. So we're about a half hour in. We should do one of your predictions. Which one do you want to go with?
Oh, man. I get to choose?
Yep.
Where are they? Oh. Oh, I don't know. You want to start at the top? Or where you want to start?
We could start with a personal one or something related.
Okay. State capital?
Yeah, that's a fun one. All right, we're going to... Ladies and gentlemen, if you're not clicking the follow button, click the follow button. Get your standard internet units. We use them on this channel to bet on science or guest-related questions. So I'm going to pop a question up there right now. It's going to be related to Billy Oates and his life experiences. So you have no real way of knowing this unless... I mean, I guess if they look at your...
Internet's loose.
Yeah. Well, you guys are all on Ask a Scientist Gaming academic honor policy. So cheating will be, I don't know. There's no implication to that. But anyway, we're going to throw a prediction up there right now. Not a science question, but a fun question nonetheless. This one you can't possibly know the answer to unless you know Billy's history. The question is, how many state capitals has Billy lived in? Is it less than 3 or greater than or equal to 3? Which is a fun Billy Oates factoid. I didn't know, and I'm happy I learned. It's not really a fair question for you guys, but also these internet points don't really matter unless you want to make us drink alcohol or request a factoid. But if you choose to do any of those things, place your bets right now. How many state capitals has Billy lived in? Greater than or equal to 3 or less than 3? I'll give you a hint. He lives in Tallahassee, which means the answer is at least 1. Is that too much? Did I give it?
No, no, that I would hope they would get that one. Tallahassee is like the epicenter of the U.S.
Oh man,
everything political starts here.
So in 2000, that was the first election I voted in.
Yeah,
obviously the hanging chads and the decision about the Florida Supreme Court.
Yeah,
stuck with me since then.
Yeah, I remember when I interviewed here. I mean, it was a few years after, not too long. It was 2006, I guess. Yeah. But I remember we were at the Doak Campbell football stadium. We walked outside. You know, I think everyone gets... Did they take you there on your interview? They must take everyone to the football stadium.
I think they might have. Like the what's the restaurant there?
The UCC Club.
You guys have about 30 seconds to guess. How many state capitals has Billy lived in? Yeah, it's the whatever, the exclusive club that you have to pay for membership. Yeah, I think we did lunch there.
So anyway, we were out there and they pointed to the Capitol. It was like, yeah, that's where we chose our president.
Yep, we chose George Bush over the Nobel Prize winning climate advocate. Yeah. Anyway. All right. So this is heavily biased. Greater than or equal to 3, 95%.
I knew that we have some internet sleuths out there.
So, Billy, what's the answer?
It's 3.
It's 3, equal to 3. So those 3 capitals are...
So if you did your sleuthing on the internet, so I went to school at Georgia Tech, Atlanta, Postdoc, NC State.
And Raleigh.
That's the other 2.
Yeah. Man, that's just a crazy coincidence.
Yeah. It was crazy because I was in Atlanta during the Olympics, which was pretty fun. They kicked us all out of the dorms. That's where they had the Olympic Village. So we had to stay somewhere off. And
96
we were,
Olympics.
It was just crazy because we would go downtown to Olympic Village and, you know, was I undergrad? Yeah, I was undergrad then. And, you know, so we were, you know, just back when I could go out and do stuff. And so we're walking back along the side of the interstate because you didn't want to walk around the entire Georgia Tech campus. So we're just walking along I-75. And they had these signs on the fence. Like Georgia Tech's right on the interstate. It's like, do not touch the fence. And so, you know, whenever you see a sign like that, the only thing you want to do is touch the fence. Yeah. And next thing you know, we have cops coming up asking us, we've been touching this thing. We're like, yeah. They were pretty cool though. They gave us a ride because they figured we shouldn't be a bunch of college kids walking on the interstate. So we at least got a free taxi ride back. Yeah, it was crazy time because I had my girlfriend at the time, wife now, come down one weekend, and I think we just went down to Centennial Park again because they would have parties down there each night. But we decided to leave early, and we get up the next morning, and bomb had gone off. Like, oh man, it was when I can think of as Richard Jewell now. He was the cop that got blamed for it.
Yeah.
I can't remember the other guy that they called North Carolina. It was crazy, right wing extremist, whatever.
Yep.
But yeah, so it's crazy times.
I remember that. So my dad actually went down and officiated the Atlanta Olympics. So he's
Really?
big. Yeah, he was like pole vault coach. He was doing the officiating for pole vaulting there. And one of the stories he recounted was the Gloria Estefan song "Reach" was just on loop 24 hours a day, every day throughout the entirety of every venue. So I don't know if you heard that echoes throughout all of Atlanta, but it was just constantly playing.
I just remember, I think most everyone knows traffic in Atlanta just sucks.
Yeah.
And so people were really freaking out on opening night. So no one stayed around. I had class, I guess. So I stayed until Friday and then left to go out of town. There was no one on the interstate. Someone used to drive.
Like a scene from a zombie apocalypse. Just Billy Oates leaving the city.
Probably is never happening again.
That's amazing. I mean, so that was a social, wow.
Yeah.
Yeah,
that was like pre-internet. So it was just, people weren't even going to risk it.
So Reese's Pieces said they read your CV before the stream, so they did their homework on
Yeah.
See, that's why we post the bio.
Yeah, okay. People are reading it.
It's to reward those that do their homework. Man. That is really fun. All right, anyone just joining us, Ask a Scientist Gaming, mediocre gameplay, expert level science. The guest today is Dr. Billy Oates, who's a mechanical engineer. He studies smart materials, but also does a lot of modeling materials, does things with quantum computing and qubits, which is another one of your hobbies, which is crazy. What I love about Billy is he has mathematical solutions to problems. He's just looking for a problem to solve. As far as, does that roughly summarize your outlook on?
I just like solving problems.
Yeah.
Some crazy problem, materials or whatever. They're just fun. I see them as puzzles. I can't believe I get paid to solve puzzles.
Yeah, exactly. Reese's Pieces says redeemed, take a drink. So, Billy, when you have a moment, cheers. Reese's Pieces, always a pleasure. Thank you all for joining us on a Wednesday night to drink and talk science, play some baseball. I've completely lost track of the game. How are you doing on this one?
Not so great.
So you're the 8?
Yeah, I think I just got doubled up.
High scoring game.
Yeah. I can't figure out how to take my pitcher out. He's like throwing 48.
Did you try the select button? Let
me try it again.
Yeah.
Oh, yeah, well, maybe
We're
next
45 minutes in. We can change games if you want or keep playing this. It's up to you.
Let's try Tecmo Bowl.
Tecmo Bowl it is.
I was having more luck at that.
All right, Tecmo Bowl. Change our stream title. Tecmo Bowl. Yeah, this is one that I played a lot as a kid. This was my go-to football game.
Let's see if I can repeat.
So Dallas, this is you growing up in the 90s. Is that why Dallas? Because they were America's team for a period of time. Oh yeah, you guys didn't see this on stream, but Billy played this a little bit when he first got here, just so I could set up mic and visual and stuff. And he returned the first kickoff to the 3-yard line.
Yeah, something like that.
Yeah, it was amazing. He the first time he played this game in 30 years, he almost scored a touchdown on the kickoff return. It was beautiful. So this one has a fun speed run too. So actually, because I played this one a lot, when I was first on the stream, I played Tecmo Bowl, and I was like, what's the speed run record on this? And the answer is something like 8 minutes. But the way you speed run this game is essentially you run around and not get tapped. The only time loss is between plays, right? So if the clock can remain constant. So it basically comes down to you run around and not get tackled as long as you can. Repeat over and over again. Kick a field goal at the end of the first half. That's how you play the game.
Yeah, that's not fun.
It's pretty amazing to watch. Well, one thing I really like is and I learned this. So I did the speed run. I was ranked 10th. I might still be 10th in Tecmo Bowl speed running, but somebody figured out that on the Japanese version of this game versus the American version, the Japanese one, Bo Jackson is faster than the American version. So that's what they use to speed run. So that's what they'll pick. They'll pick Bo Jackson as a running back.
That's who I was trying to think of last. I remember Bo Jackson.
Yeah,
legit. On this thing.
And Walter Payton is pretty good too.
Oh yeah. See, I was picking Dallas because Herschel Walker's on it.
Yeah. And what's awesome about this is they got actual player names.
Yeah.
Which is not common in.
No, pre-Madden.
Yeah. And exclusive deals, and Michael Jordan never showed up on anything except Jordan versus Bird. Classic. All right, so we should do another Billy Oates origin story because one of the questions we'd like to ask is what got you to where you are. So I'm going to put up this prediction now. All right, if you're not following, click the follow button, get your standard internet units. We're going to spend them on another Billy Oates question. We'll get to science questions eventually, but we're going to do some origin story stuff first. So the question here is, Billy is now a mechanical engineer. What brought him to mechanical engineering? Was it a diesel mechanic or a girl? Or what the language is, what attracted Billy to mechanical engineering? Attracted, that can be a distractor. You did some test analysis stuff at one point, right? Based statistics on testing.
No. Oh yeah. That's right.
Because one of our early NFL, that was the broader impact, right?
It was there's this other thing called evidence theory.
Yeah.
So early on, I would just ask students, what would I do? I would ask them before class, what's your level of understanding of this topic? Because you can give notes and stuff beforehand.
Yeah.
And then I would ask them again after the lecture to see did I actually teach them anything useful. And then I would give them a quiz. And so there was some interesting statistics on this. I think, I would have undergrads and graduate students in this dualistic class. And so I think the statistics so what I thought was going to happen was they were going to over predict what they thought they knew, right? But it's engineers. I think they're kind of conservative. What they think they know, they don't have the Dunning-Kruger effect quite as much. Fortunately,
you need to do that for a pre-med class.
Yeah.
10 seconds left. What attracted Billy to mechanical engineering? Is it a diesel mechanic or a girl? Very contrasting scenarios. We only got one vote in.
You're not going to find this one on the internet.
His biography is not released yet. The movie about Billy Oates is yet to come out. But Ecstatica, thank you for the Prime sub. We really appreciate it. You guys don't have to sub, but if you do it through Amazon Prime, because Jeff Bezos writes us a check directly and it doesn't come out of your pocket. But Ecstatica said, buy Dr. Oates a beer with my Prime subscription. Make sure not to spend it all in one place. We didn't. Cheers, Ecstatica. Thank you as always for joining us. We really do appreciate it. And if you have questions, throw them in chat. Speaking of questions, what attracted Billy to mechanical engineering? Was it a diesel mechanic or a girl?
Yeah, it was a diesel mechanic. There's a story behind that. And so for the record, so Ken slightly adjusted my my answer. I had put girls.
Yeah.
And the thing is, I went to Georgia Tech back in the 90s, right? And so maybe they've gotten better on diversity, but at the time it was maybe 10 or 15% female engineers.
Yeah. Yep.
And so I transferred into Georgia Tech. I went somewhere else, Georgia Southwestern, where I played baseball for 3 years. And at the end of that time, you know, I was just playing baseball. And, well, I had to get good grades. I did study. But when I had to transfer in as this dual degree, they asked me, well, what kind of engineering? And I was looking at all these things like, civil engineering, what does civil mean? It's like electrical, I don't like electrons. I don't know what they do. As I mentioned earlier, my dad was a diesel mechanic. So it's like, well, mechanical engineering, check it. And that was it.
It was destiny.
Yeah. Didn't look back after that.
That's amazing. Well, I mean, I'm glad you fell in love with it.
Yeah, it worked out. It's like, yeah, I know how gears work.
Yeah.
You know, I open the hood on my old car and stuff all the time, so I figured I could hopefully at least do that. I mean, I took classes. I don't know if they still do this. I took classes on how to design bolts and, you know, stresses as you pre-torque a bolt. So, yeah, right up my alley.
So that worked out.
Yeah.
That was really it. You were just like, which one
Yep.
is engineering do I want to do? And
Yeah, I had really no idea.
that's amazing.
I mean, industrial engineer, I was like, what is this? Study of industry or designing industry?
So how hard would it be for you to cross those boundaries now? Like, presumably you could apply your knowledge to any of those problems.
Yeah, I mean, I don't know how far after PhD goes, but, you know, if you teach a few of these classes, then it's not that much different, I don't think. There's devil in the details. If I just had to go and teach a class on, I don't know, computational fluid dynamics, I would struggle.
Mm-hmm.
You know, if that was the only thing I had to do, it'd be okay. But yeah, I like doing a lot of different stuff.
Yeah.
So,
I was going to say the polymer work is borderline chemical engineering,
Yeah.
and material science.
yeah.
Speaking of which, cheers, we got our paper accepted.
Oh yes, yes, that was awesome.
Battle.
Yeah, that took a while, but worth it.
Wow. So Billy and I started a collaboration when I interviewed at FSU. I don't know if you remember that.
Yeah, I think I was on that search committee.
Yep. Yeah. So you were one of the people I met with in 2013, and I remember the interaction. It was something along the lines of, "You do light stuff. I'm trying to bend polymers with light. How do we make this is like more efficient or lower energy light?"
Mm-hmm.
And it just gradually evolved over several years, and we finally. I mean, we had several like conference proceedings before this, but like the paper is out.
I mean, that was, we did a ton of work. It was just a matter of, you know, are we going to focus on writing some proposals or just get this out in the literature? So glad we finally just got it out there.
Yeah, and we're going to have a press release at some point. which I'll share.
Yeah.
If you guys are interested, here is a link to the paper. Enabling low-energy light harvesting with still beam-based photomechanical polymers via triplet sensitization.
It's a mouthful.
Yeah, it really is. I mean, it captures what we're doing, but there's an analysis basically saying, you know, shorter titles give more citations. And we completely threw that scientific method up. But anyway. Oh.
Yeah, when Ken told me about that, I was like, this sounds like black magic. Just go through the back door and make these things bend with these different light and chemistry. It's amazing how that works.
Tribal luminescence. What is still beam?
Oh.
As in two separate words. I'm 100% sure tribal luminescence know what still beam is. But that was worth a laugh. Thank you, tribal luminescence. Still beam. Is that a paper about a dancing bean? Kind of. Like, you're not that far off. I don't know, Billy, do you want to explain that? Like what
I'll
we
give
did.
you my basic, and then you can correct me. So it's basically two benzene rings that are connected with a carbon double bond,
Mhm.
and they're basically straight rod like structures with the benzene rings on the end. They're about 10 angstroms long, and that's their low energy state. But if you excite them with the right frequency of light in the deep UV range, they'll change their shape. They'll shrink by about almost 50%, I think.
Yeah, that's pretty
Five
big.
angstroms almost.
Yeah.
And if you stick that in a polymer, then you can pull the polymer with it, and that allows you to do all kind of cool stuff in smart materials. So we usually have to use electricity or big magnetic coils to do this, but you can just do it with a laser pointer. So that's what a steel beam is. It's like the underlying molecular motor to move polymers.
Polymers are roll. What is your molecular weight? We don't know. Reviewers actually asked that to us. So we got a hard time on this paper.
Is that one of our reviewers?
Hey, that reviewer number 2 right there. Billy, the new chemistry faculty confirmed. Let's do it. Affiliate status. We joined and mentored a postdoc at one point, so yeah, let's do it.
Yeah.
But yeah, molecular weight question is hard. So this is it's a polyamide film, but it's not soluble at all. So we couldn't do any of the normal like GPC or like any of the molecular weight analysis stuff. So we basically had to use IR to say the reaction went to completion. Presumably they're very long chains, but we don't actually know for sure. But yeah, it's really cool. Shine light on a polymer. That polymer can bend. You can do work with it. The bicep curl measurement you guys do is my new favorite. Where essentially it's exactly what it sounds like you're doing a bicep curl to lift weights. In this case, the weight is Scotch tape, and it's a polymer lifting that Scotch tape, which is kind of cool.
I mean, early on when we were doing this with azobenzene, we should mention this is in polyimide,
Yep.
and we did this in some other polymers, polyacrylate. The point is they're both glassy. So when we were doing this for some DARPA project, a lot of people were saying there's no way you can get these 10 angstrom molecules to bend in a glassy polymer. And sure enough, you can. You can get them to, if you use the right wavelength, they'll go to this kink shape I mentioned from the trans or rod shape. But if you use polarized light, you can actually get them to eventually rotate through this intermediate random cis state. So you can get all sorts of bidirectional bending, twisting into crazy shapes, all sorts of cool stuff.
Yeah, one of the cool things about these polymers, something that intrigued me a lot, is that so you have the polymer like this. If you use vertically polarized light, you bend towards the light. If it's horizontally polarized, it bends away from the light. And so you can control the directionality of the polymer based on how you control the light, which is pretty crazy.
And if you're really good with this, like a colleague of mine that at the time was at AFRL, Tim White, he invited me up to show me his lab, and he got this thing to work when we were in there. So he excited one of these things, and it bent toward the light, and it'll bend like 90 degrees. And so if it'll bend just a little bit more past the light laser beam, it'll get excited on the back of it. So then it'll try to bend back the other way, and then it'll get bent on the front side. It'll bend, and it'll start fluttering like this little hummingbird.
Yeah.
So I mean, you can get them to move at super high speed. Then it's just based on the resonance of the structure.
So Ecstatica has a fun question. My dad works for a natural gas company here in Florida, and he is always interested in topics related to energy. He's a big believer that everything has a consequence when it comes to energy harvesting. He always brings up the idea that we might not understand the full side effects of wind energy harvesting. He argues that stopping the wind might affect the Earth's rotation or something. I don't know how to approach this question. Any thoughts? It's a big one.
Yeah, I mean, I don't know about the bigger consequences, but on a smaller scale, there's piezoelectric materials that people are using or trying to use for harvesting vibration, turning electrical energy. And the Army had looked at this for a while back, and they stuck them in Army boots, because folks are always rucking and you get your troops on the ground, so they could generate that so they wouldn't have to carry as many batteries. Well, what they didn't realize is all the troops started having back problems from having these things in their boots. And so it is interesting that you can have these consequences you haven't thought about.
Yeah. These very subtle but long-term attrition problems.
Yeah.
Yeah, that's something I've thought about, even with solar cells, right? You're taking photon energy out of the atmosphere. Like, how much does it take to actually perturb the system? And I'd argue because the ocean dominates most of our surface area, I don't think what we do on land is going to matter that much. I mean, it's over 50% ocean, right? And that's where a lot of the wind energy and thermal energy is stored. I can't imagine us stealing that much energy out of that system. But the person to ask would have been Allison Wing, actually, who studies hurricanes and models tropical storms and how they form. Interestingly, so she was on, it was over a month ago now, but I mean, she talked about their data sets, right? They have like 2 terabyte data sets, and essentially they model these hurricanes with the vector forces, essentially. So very similar to, well, not similar to, but what you've done with the mechanical films, right? The vector addition math. That's how they do hurricane modeling, which is kind of crazy. But yeah, it's interesting because one of the conclusions, or recent, I don't know how recent it was, but climate change, like atmospheric warming, is not going to increase the frequency of hurricanes, but will likely increase the magnitude of them, because it's just a force problem. It's an energy propagation problem. So if you do that math, hurricanes become more intense, which is kind of fun.
I remember when I was at Sandia some time ago, we were talking about these photopolymers, because you may be familiar with these heliostat fields where they have these big mirrors. I think these mirrors are on the order of like garage-sized doors. And so they'll have pretty big motors that'll track these things. And I didn't know the equations were so complicated to track the sun as it moves over this complicated path. And you got a huge number of mirrors, so each one has to follow a certain path. And so it's a decent parasitic load on the motors that move these big mirrors. It's like 20 or 30%. And so we had this idea, can you use much smaller mirrors, put these photopolymers underneath it, kind of like how sunflowers track the sun over the course of a day. Still early stages, but yeah, folks are looking at this in all sorts of crazy directions.
Ecstatica has redeemed Take a Drink. Are you still good?
I'm good. That is a good one. I'll have to put that one on my list.
Yeah, Market Square Liquor.
Okay.
It's a nice little international shelf. Ecstatica, cheers. Thank you for the question. I mean, that's a really big, fundamental question. Like when we think about COVID, right? And so you can say the number of deaths from COVID has been non-trivial, but I mean, it's not bubonic plague type numbers. But the thing that I'm really wondering about is, we talk about long COVID, the neurological effects of COVID on people. Like, what does that do across 1 million people? Because it doesn't have to be a huge change to add up to massive numbers when it's so many people. Like if you have a cumulative IQ drop of 2 points across, 100 million people, what does that do to society? Like, I love those big questions.
Yeah.
It's a sociology problem, and I'm sure we're going to see crazy implications of this. One interesting one is we talked to a chemistry high school teacher fairly recently about educational stuff, and basically they were saying the year off due to COVID, you saw basically an entire generation of kids that lost a year of high school. Mm-hmm. Like, what is the implication of that long term, especially going into college, taking Gen Chem in college?
Yeah, it's going to be rough.
Yeah. Can probably be described with a fractal, right?
I think the number of people who have come back to work is a fractal dimension of some sort. I don't know if that's good or bad. It'll be interesting to see how productivity changes. It'll be good. Well, I mean, I'm sure there'll be a distribution, right? I'm sure some people can thrive and, not have to go drive 30 minutes or however and get more work done or spend time with family. But I think there's a part of the population out there that needs support from others to stay on the ball.
Yeah.
And I wonder which group is deciding to come into work.
That's a good question. I mean, you see it with grad students too. Like some are going to be productive no matter what.
Yeah.
I mean, how devastating was the shutdown for you?
I mean, since I've done a little bit more modeling these days, hasn't been that bad. So I haven't been affected that much. But yeah, we got folks that, do wind tunnel tests. They got to be in. It was kind of rough early on for them because, most of that is Department of Defense. And they don't just stop the wars because COVID's going on.
Yeah.
So Air Force kind of needs that work done.
Yeah, Ecstatica. I was not a productive grad student during COVID, especially when stuck at home. Yeah. Now, my group had that issue. We do wet chemistry. We do actual measurements. It was it was hard. It was really hard.
Yeah, I think just talking with friends, working stuff out. It's hard to schedule random question that you're going to have that you could normally just talk to your office mate about.
Yeah, one of the things I noticed too is the incoming cohort of grad students. Like they came into a COVID work environment. Like, and there are things like work culture in groups where, you have certain workforces that establish a culture where everybody wants to work and they want to be there at this certain time interval. And COVID just completely destroyed that because there's no consistent schedule. There's no reference for that. So are you winning right now or you're still up?
I don't know.
17-14. I can't remember which scores. Yeah. I think you're the 17.
Maybe I'm up. Okay.
Yeah, you can kill the clock.
I gotta hold this fourth quarter too. All right, I just got to hold the ball.
Yeah, Reese's Pieces. Even for those of us that whose work can be done remotely, meeting in person is essential for scientific discussion.
Yeah.
Yeah, I agree. I mean, now you just got to score out of spite, right?
Oh yeah, Herschel.
There it is.
Oh, it happened again.
I mean, 11
seconds
to kill.
All right, just don't
run it out.
Don't do like a Jameis Winston pick six right here.
Yeah. Oh man. Or the Seahawks. You remember that in the Super Bowl? The last. When was that?
Was that Seahawks and who were they playing? I know it was. New England, I think. Was it?
Maybe.
There was like this or was it the Saints? Someone got these games get mixed together, but it's either the Seahawks or the Saints got kind of gypped on some kind of play down near the end zone. So maybe mixing up my playoff and Super Bowls.
Yeah, I do not keep track of sports as much as I used to, but I remember watching that game because it was the last 30 seconds of the game.
Yeah.
They were on like the 3-yard line. They had a beast of a running back that could just steamroll everything. Yeah, it was New England. They could have won running the ball, but they went for a pass play and it got intercepted at the line.
Yeah.
Like
that may have been it.
Devastation. Ecstatica wants to know, does the bar that pops up when you kick the ball actually do anything?
No. I got a situation.
Oh, it doesn't matter.
Oh yeah, I'm still. Okay.
You still won. They beat the spread though. Where's our prediction there? Where's your students modeling?
Yeah.
But the bar does do something that indicates the strength of your kit, which presumably you want it high, unless you're trying to speed run it. Then you want it exactly right so it doesn't go too long in the air. But yeah, it was Seahawks versus New England. It was on the goal line. That was brutal to watch. All right, congratulations on your victory.
Speaking of that, though, you know, growing up in Georgia and being in Atlanta, I'm a Falcons fan, and that 28-3 thing always seems to come up. I don't know if you followed. We were watching this at someone's house in my neighborhood. I was a big Falcons fan. They were playing the Patriots that year. They were up 28-3 at half, and then they lost it.
Oh, that's a playoff game, or that was
no? It was a Super Bowl.
That was a Super Bowl. I don't remember that. Oh my God.
Yeah, I'll never live that one down.
You're still a fan?
Yeah, still a fan.
That's brutal.
Yeah. For punishment, I guess.
Yeah, I guess we should do another prediction. Let's do a science one this time because we got a bunch of these guys to deliver. What do you want to talk about? What do you want?
I mean, we were playing baseball earlier. How about the one on finger forces?
Ooh, that's fun. It's a homework problem from class. All right, so we'll have to give some context on this one because presumably the objects have to be dropped or...
Yeah, so I can give you some interesting context on this one. So,
all right, so the prediction is up. The question is, finger force from a 90-mile-an-hour fastball is approximately equal to 2 cinder blocks or 11 bowling balls.
So, actually, this can be tied all the way back to Ask a Scientist when you're doing this at the Railroad Square downtown. So Greg Erickson was at one of those, and we were talking, and I guess I mentioned I played college baseball. Anyway, a little bit of time goes by, and he calls me a few weeks later. Some morning, working on something, he's like, "Hey, didn't you tell me you played college baseball?" It's like, Greg, I got a proposal due. Just wait. He said, "Well, the Yankees called me, and they want to know if someone can measure pressure on the baseball for pitchers." It's like, okay, you got my attention. I said, "Are you sure you're not being catfished by the Yankees or some scam?" And he's like, "No, it's legit." And so we went down. It was in spring training, so we went down to Tampa where they do this and got to meet some of the guys, the players, the trainers, and they had all these cameras. So this guy they brought in, they could, measure velocity and spin, measure kinematics of the pitcher, his motion, and try to relate these things. But you can't figure out where the motion comes from. You need to know what the forces are.
Yeah.
I didn't know how to do that. And so using some of the smart materials we use, I said, yeah, we can integrate this in here. I said we could probably build a sensor for about, fund the students and materials for 30 grand or so.
You lowball them. You should, $1 million. We can figure this out.
They told me, they're like, wow, I didn't know it would cost so much. It's like, the funny thing is, so I had a PhD student that graduated some years ago, and his dad worked in the front office for the Yankees. So I know what they can afford.
I was going to say, they spend that much on, grass maintenance.
Yeah, I mean,
millions.
I mean, they pay, I guess, most of the budget's probably for players, but still. And so we've been bootstrapping to make this sensor, and I'm just going to sell it to the Braves.
They didn't give you anything to work on it?
No. Wow. No, I think they just had no idea what it takes to build a sensor or any system, and they thought, oh, they'll make this thing, and when it's ready, they'll sell us one for like $100, I guess, something like that. But
so they don't want to pay for the R&D; they want a product.
Yeah. So I did some scoping calculations on this, and then it was interesting anyway. Figure out what these forces were.
All right, so the answer to this question, the force off the finger force from a 90-mile-an-hour fastball is approximately 2 cinder blocks or 11 bowling balls.
11 bowling balls.
Oh, nobody guessed 11 bowling balls. Everyone chose two
I wouldn't have
blocks.
guessed it either. Because
It's a lot of force.
I saw this on Wired.com, and they said 11 bowling balls. Like, and this was many years before this come up. I was like, huh, there's no way. And then once I did this, I was like, oh, I need to go back. I want to see if those numbers are really right. Turns out, yeah, if you just do it based on a fraction of a second, and roughly it's when you're holding the ball, to accelerate it from 0 to 90 miles an hour. I think it's 120 gram baseball. So you just run those numbers on Newton's law. It's a huge force. It's crazy.
That's a fun analysis. All right, so the answer is 11 bowling balls, which is a shitload of force to be off fingers. And I do this like dozens and dozens of times. Is it 100 pitches per game?
Yeah, you're starting pitcher sometimes 100 times.
Holy
plus
shit.
warm-ups.
And you're talking like 10, 15-year career. That's...
Yeah. It seemed like now, just watching my kid come up through high school, now even like senior students or college students is getting this Tommy John surgery, where they take the bigger tendon out of your Achilles, put it in your elbow.
Yeah.
Then you can really sling it.
What was the movie in the 90s, the kid that broke his arm? What was that called? You know what I'm talking about?
I don't know. Is it like based on a true story or
No, it was a
fiction?
cartoonish.
Oh, okay. Like some little kid that then made it to the major leagues or something.
Yeah, he like broke his arm and it healed back weird. Where he could like pitch 90 miles an hour.
I don't know if I watched that one. I think I've heard of it.
I promise I will look up the name. If somebody knows it, throw it in chat right now. It's absolutely ridiculous. Speaking of games, what do you want to do? Do you want to do more Tecmo Bowl or do you want to move on to something else?
Oh, let's try something else.
What do you want? We got Pitfall, Cubert, Super Mario Brothers.
I haven't tried Pitfall yet. Let's see if I remember how to play that one.
So this is a port for NES. So they took the Atari version and threw it on the NES so you can use the Nintendo controller.
Cool.
Texan, welcome back. It's been a while. Yeah, 2 weeks ago when we were supposed to have a stream, I was supposed to go to a conference in Mexico, so I wasn't going to be here for a stream, obviously. But then I ended up getting COVID the night before I was supposed to leave. I don't know if you heard that at the Quantum meeting, but like...
Yeah, I remember you mentioned that.
It was terrible. So I was supposed to get on a flight at 5:30 in the morning, and I woke up at 3 a.m. with a headache and like fever and cold sweats. And yeah, tested positive for COVID the next day.
Where was the conference?
It was in Cancun, Mexico.
Oh, that's right.
Yeah. So I would have been, so you need to get a negative COVID test to get back in the United States. So I would have been stuck in Mexico at it was basically a resort for about a week until I recovered. Yeah.
Definitely got to get that insurance. That would have paid off if you got it right.
Well, I looked at it after the fact, and the stuck at a Mexican resort, exactly. No, they had this insurance policy that was like $4 a day to cover COVID emergencies. And if I had gotten COVID, it would have been an additional $10 a day to stay at the resort. I'm like, $10 a day, all inclusive, food, everything.
No kidding.
Yeah. Do I regret? No. Debbie would have murdered me if I was at a resort.
Take it for the team sometimes.
Yeah, exactly. But yeah, Texan, welcome back. Field work in the woods, that's fun. That's one thing we're missing. I guess you got to do some field work at a training camp.
Oh, yeah. Fort Polk.
Yeah.
So there was some crazy stories there. So this guy that this little bit. This guy, he ran he was like the gunner on a tank. You'll appreciate this one. There was a few other faculty there. There was a guy, I think, from Penn, and he studied this special kind of polymer that would break down in blood. And when he told this guy that these 50 cal of a tank, I've never seen his eyes get so big. It's like untraceable bullets. I mean, imagine that. Bullets that would dissolve in blood.
Yeah. Somebody thought of an application. Your physics are letting you down on this one.
Yeah, I don't know. I'm blaming it on the controller. I don't know what's going on.
I think you have to release.
Oh, there it goes.
Yeah.
There it goes.
You have to use the.
I think it's the
parabola?
timing.
Yeah.
Right. I remember there's a trick to this thing. That's not it.
Texan, I'm working on a paper that ended up being more controversial than I wanted it to be. Oh, I didn't know you could stand on their heads like that.
Yeah.
Look at this veteran gaming we have here.
Oh, man.
Tears paid off. Yeah, controversial papers are both fun and terrible at the same time. Especially if you get shit on by reviewers for it. But we do have a rage emote if you want us to invoke it. It's Aaron Vanucci, one of my colleagues. He's a professor at University of South Carolina, but he rage quit Madden in 2006. He got an interception in the fourth quarter. He just walked off. He went and got a drink, but still. It was pretty excellent.
Yeah, my son has told me if you rage quit, is it Fortnite? You get banned for like a day or something.
Yep. Yeah, those multiplayer games have rules now. Oh, does your son play Fortnite?
A little bit.
That's a popular one. I never got into it. Anyone that's been keeping track of the stream, you guys will be happy to know I finally beat Halo Infinite after 6 months. I got it for Christmas, and you don't get enough time to play, you know?
Which one is this?
Halo. I don't know if you're familiar with the Halo franchise, but the latest version of that. Like, I played the original Halo in 2001. Like, that was my bread and butter college game, but... Texan following up on the project. I'm using Landsat data to detect small, ephemeral bodies of water, sub 15 meter. In the state of Texas, you can build a dam that is 200 acre feet, and don't need a permit. Turns out that's a boatload of water for cattle. It's all cattle ranchers. That's fun. That's controversial. What makes that controversial? Man, the water shortages in like Southern California, and so I don't have infinite lives for this game, unfortunately. This one's old school brutality.
I forgot how brutal this one is.
It's unforgiving. All these early games were not forgiving by any means. All right. Ladies and gentlemen, if you're just joining us, Ask Scientist Gaming, mediocre gameplay, expert level science. Guest today is Dr. Billy Oates. He's a mechanical engineer, also a mathematician, likes to model things. He talks about soft materials and fractal modeling and quantum bits. Whatever you guys want to discuss, throw your questions in chat. Because the ranchers have a lot of pull. The environmental guys are stoked about it. But it's going to get me kicked off every ranch on the Brazos. I mean, that's fair. They have an incentive. Oh, I didn't know that. So 200 acre feet is the amount of water it takes to fill 200 acres 1 foot deep. That is an interesting metric. I've never heard that before.
No.
Huh. But it's a clean way to define a volume rather than, well, I guess you could do meters cubed or something like that, but acres for landmass makes sense. Basically the volume of 200,000 king-size mattresses, and you don't need a permit. King-sized waterbeds is the analogy there. I like it. Man, that sucks how controversial that is, because everyone has an agenda, right? So I did this congressional briefing in Washington, D.C., and it was basically predict what the world's going to be in 2035. And mine was obviously solar cell related. I said, basically, we're going to have solar cells on top of carports, and they're going to charge these electric vehicles that are going to be self-driving, which I hope we have by 2035. But at the end of this briefing, the moderator asked a question, what outside of your area or discipline do you think is going to be a big thing in 2035? and mine was synthetic meats. Synthetic meats are going to be a big thing. They're going to take over as soon as it becomes cost effective to make meat synthetically. You're not going to know most of your fast food restaurant source of meat. That's just going to happen. And what was interesting is there was a biologist on the panel with me, and they're from Nebraska. And so they were like, I couldn't possibly say that publicly or I'd get hung in my home state because you rely on agriculture so much.
Yeah.
Despite it being 100% true, synthetic meats will take over a good portion. What is going on? You have to go down in the...
I don't know how to get past that cobra, and now it's not there.
Wow. The aggregate area of these small bodies of water is just one Landsat image is 45 times bigger than the largest lake on the reservoir. That is crazy. And so you're doing analysis and figuring out where these are. Oh, nice. There we go.
Oh.
What the hell kind of landmass is that? Largest lake on the watershed. That's really cool. I mean, so the paper's not controversial in terms of writing it up and publishing it. Presumably peer review, it's okay, but you're going to upset a lot of people politically and socially at home, which I guess makes sense. That's fair. I love the scorpions. Like, they really captured the essence of a scorpion. So if you press start, I don't know if you're familiar with this map, but it shows you how many levels exist in this game.
Oh my god.
So you're on like level 10, 200 something. It's the original quarter eater style.
Can you get 3 lives total? I don't ever remember getting extra life.
Wow. There are an estimated 1 million on the basin. My old mentor hired a technician to go through manually through 3 counties and put points on all these small bodies of water. Texan Space Agency used machine learning. That's fun. Man, I honestly did not know you could stand on the alligator heads. I tried to speedrun that every single time. Because who played this? I think Christina Holmes played this game during her stream. And I play every game the guests play before they do just to make sure they work and there's no issues.
Yeah. It's my Pitfall hack.
Speedrun. Speed strat. But anyway, if you guys have questions about smart materials, qubits, quantum computing, we haven't even dove into that one yet. I guess we could with some of our questions we have coming up, but yeah, Billy's happy to answer any of those questions or talk about Pitfall and his various hacks he has invented for this game. So how's it been playing and talking science?
Yeah, it's rough. Oh,
high score though. Congratulations, scoreboard.
I mean, in the emulator, does this thing stay in there?
No.
So like,
I mean, I could screenshot.
It's like that Seinfeld episode where they have to try to take the Frogger game across the street.
Yeah. I mean, got to protect those scores. They're immortal. Texas Space Agency wants to know, smart materials, how does a ShamWow work?
A what?
A ShamWow. It was an infomercial late at night. Do you remember this like towels that everything? I mean, I'm sure that's an amazing
it has a special fractal dimension to absorb all the water.
It's a super high surface area material plus a hydrophilic surface coating. Yeah. I'm sure it's how you make the foam that's important and not the material itself.
Yeah. What?
ShamWow. It's been a long time since I heard that name.
Yeah, I'm not sure what he was talking about, but yeah, I remember those infomercials. I don't know what this custom thing is.
Because that was, what's his name? Yeah, Vince Offer. He was the voice of ShamWow, and then he he like assaulted a hooker or something like that. It's a weird backstory. But he was the late night.
One of the original cancel culture.
Yeah. This, you remember this?
Oh yeah.
The ShamWow guy. I don't know how I remember that, but thank you, Texas Space Agency, for bringing that one up. What is Flex Seal?
Sounds you guys are watching a lot of late night infomercials.
It is. It's the paint you put over things that's presumably hydrophobic and also seals things.
Yeah, doesn't work. Don't try it.
Yeah. Any miracle material somebody has come up with, I mean, if it is not mainstream in the industrial community, it is not real. Most of those products, they're probably not effective. But who knows?
There's one I've got at Home Depot. Not that one, but I at least know some guys in construction, and they're like, "Yeah, get this stuff. You'll patch up your roof." Yeah, it worked.
Was it Flex Seal?
Was not. I tried that because I was at my wit's end on trying to get this thing to fix. No, it didn't work.
Yeah, it's just bed liner, canned bed liner with an aerosol. Plasti Dip is the same thing. Yeah, it's just it's polymers, right? The like quick set polymers that you can coat things in. I mean, what I'd be curious about is like how well it adheres to the surface, and then how long it maintains under sunlight and heat and all those variables. So you're on the level 11.
I hit custom thinking it would give me something interesting.
Oh, it's just empty.
Yeah.
Here, I think I can reset you.
Yeah, maybe you can do that.
There you go. Get you back. Did they call it Mestatic? Mestac? Fixed glassware with it. That's fun. I don't want to belittle all these. Some of those products are really amazing at what they do. But Mastic? I don't know. I'm not familiar.
Now, if they were saying mastic with an N, I think that has more to do with a special smart material based on plants. But mastic, I'm not sure.
Wow. I mean, so what classifies something as a smart material? And there's materials with complex materials.
Yeah, it's a good question. I mean, usually in the smart material community, they usually define it as stimuli responsive. That's not straight stress and shape change. Something that's indirect. You use some other type of energy transduction mechanism, and you'll get a change in shape, or vice versa. You can get shape change, and that'll generate some kind of electricity or light or magnetic field. I mean, one of the cool ones I worked on early on at FSU was Paramagnetic Magnetostrictive.
Yeah.
And there's one pretty well known Navy come up with called Turfenol, but it's brittle, so you have to compress it and you have to put it in this big structure. The Navy still uses it for sonar, but there's this other one called Galphenol, and
Wait, so they use magnetic fields to induce the sound wave through this material?
yeah. Yeah, so you get a big enough. It's I think it's technically ferrimagnetic, but you get a lattice distortion from a magnetic field, and it's small strain, but it's really big power or big forces.
Oh.
We were doing one project called acoustic spoofing for the Navy, and so since you can generate all these sound waves, and you could do it really loud, the Navy wanted to put it on a pontoon boat, make the pontoon boat sound like the USS Alabama or something. So you play games in the water. And they took this thing out in the Chesapeake Bay, like a mile out, and you could hear this thing from the shore. It's just crazy how loud these things are. I mean, it was only about this big.
Yeah. So they want to like mess with sonar based on
Yeah, just
paddle boats that
yeah,
sound
you know,
like
make it
aircraft
sound like
carriers.
you're this big aircraft carrier.
Man, that is a solution to a problem I didn't know existed. Like, that's amazing.
Yeah, it turns out every aircraft carrier has a distinct acoustic signal,
Huh.
and all the enemies know which one's which.
Carbon nanotubes can alter the reflective signature of visible light. Does that work with thermal radiation too? I think nanotubes are thermally conductive. Because graphene was another one that we're really interested in.
Thermal, huh? So like absorbing phonons?
Yeah.
Is that what they're asking?
Yeah, so dissipating heat energy so it doesn't do like a infrared signature.
Some people are looking at trying to absorb infrared.
Yeah.
Not sure where that technology is. That would be
that's
pretty cool.
Thermal I have not. I mean, I don't do all photon driven stuff. Could I make a black body out of a carbon nanotube? And it depends what it does with that energy. I doubt it. And the hard part about carbon nanotubes, and I think this is really underappreciated, is that carbon nanotubes are not all the same. There's something called, I don't think the term is chirality, but it's basically how does you have a sheet of graphene, right? And that sheet of graphene can wrap around itself, and can wrap around itself a square, or it can do it in a helices, and it changes things like the thermal conductivity and the electrical conductivity and the optical properties, depending on how that tube wraps into a tube. And so there's different, I don't know the formal nomenclature, but basically they have different numbering schemes depending on how it wraps upon itself, and that changes the properties. And one of the really hard parts about these tubes is when you make them by most methods, you make the distribution of all these different types of tubes, which means you have an average of all these properties. And so, yeah, that's one of the things that's fundamentally limited. Like, carbon nanotubes were a super popular buzzword, 20 years ago. And there's very few commercial products that actually use carbon nanotubes. I think they're used as a lubricant for certain materials.
Graphite.
But they've used nanotubes for that as well. But in terms of electrical properties, it's so hard to isolate those different versions of it. That's why it's not used as much as it should be. It's just too expensive and their properties are too close. But yeah, minor detour. All right, so we should throw another prediction up there because we're 9:37. We have several of these guys left. Which one do you want to do? Nutrient intakes in plants. That's fun. An indicator for nutrient intake in plants.
We went down one on quantum computing.
Which one?
Qubits. Simulate.
This one right here?
Yeah.
Oh, that's a fun one. I'm going to be really impressed if somebody actually knows the answer to this one. I'd never heard this calculation before. Pretty amazing. All right, if you're not following us, click the follow button. You're going to get a bunch of standard internet units that you can spend on our channel, but you can also gamble them on science questions. And so we're going to pop up a science question right now. And that question is, how many qubits, so qubits are quantum computing bits, so not ones and zeros, but actually quantum information bits, so quantum computer. How many of those qubits does it take to simulate all particles in the universe? By this we mean, if you do the math for the total number of particles in the universe, and you want to do a calculation based on that total number, how many qubit bits would it take? Is it greater than 230 or less than 230 qubits? Which is crazy. So how many bits would it take? A 0-1 bit be like 10 to the 100th or something crazy, right?
Doesn't scale well.
Texas Space Agency, at least 12. I don't know, you'll be impressed by quantum computing powers. Maybe it's 10. We don't know. But Billy's done the math. He knows what the answer to this is. Qubits to simulate all particles in the universe, less than 230 or greater than 230 qubits. And so this is basically quantum bits, which aren't ones and zeros. There's something very different than that. How many of those does it take to calculate all the particles in the universe? This is a perfect quantum computer with greater than or less than 230 qubits. All right, you have about 30 seconds left. Throw your guesses in there now. Is it going to be greater than 230 or less than 200? Says this one you came up with, or you found this one?
I knew how it scaled, but I had to look up how many particles in the universe.
Then he did the math from there.
I had to check with the physicist on that one.
Yeah.
Apparently, there's some ways you can do that with telescopes.
To estimate that.
And a few other ways that I've forgotten. But yeah, so it's ballpark number.
I mean, order of magnitude, I think it should be close. All right, Billy, so what is the answer? How many qubits to simulate all particles in the universe?
I gotta remember my number. It's, 267.
267, so greater than 230, but not much greater. So if you have 267 qubits working perfectly and you execute a calculation on the number of particles, which in this case is, what the hell is that number? 3.28 times 10 to the...
I think it's 80.
10 to the 80th. Then you can calculate it with 267 qubits.
Yeah, I found it interesting. The number I found was, this according to the internet, 3.28 times 10 to the 80. Not just 10 to the 80.
3 point, I mean, that's probably a
big.
mass balance problem, right? As they say,
Maybe.
here's what the mass of the
Yeah.
universe has to be, so there must be this many particles. Jeez. So 267 qubits. If you have a computer that has 267 quantum switches, you can essentially calculate every particle in the universe.
Well, there's a lot of caveats on that.
Yeah.
I should mention in case you guys are interested in getting into this. So you can simulate that on the quantum computer. You can't measure them all. We don't have enough particles to measure all those outputs.
Yeah.
And as soon as you measure anything quantum-like, it collapses onto a finite number. So in the end, you only get 267 answers if you measure them all. Each quantum qubit, it's going to tell you 1 or 0 and some basis that you measure with your hardware. So yeah, that's the one caveat. But you may only often, if you're doing optimization, you just want the optimal solution. So that's one of the main ideas of quantum computing is go search over this big space and just give me the answer, the optimal solution. There's all other sorts of caveats in there too, with noise and error correction you got to do. So this is like the thought experiment.
I mean, there's some discussion about the physical impossibility of something. Like, you can't exactly do it, so you need redundancies for every calculation. And
Yeah.
how many qubits can you get to couple together to give you an actual meaningful signal?
Mm-hmm.
Yeah. But
Yeah.
theoretically,
Yeah, it's basically like, just with bits. Sometimes they'll flip the wrong way, and so you'll have enough of them and you sum them up, and then you just do majority voting. Some of the error correction codes are, in a sense, like that, but
that's
quantum
interesting.
mechanical. Yeah.
So there's going to be some uncertainty analysis of quantum computers. There has to be.
Yeah, it's called, one of the most popular to correct errors is called surface codes, and you basically have to have so many extra of these qubits to get one bit of qubit information out. Google and both IBM and Google have this goal of 1 million qubits know if they put a date on that, but 1 million qubits, that would be crazy if they could do that.
Well, especially now that like the computers have to run at what, 4 Kelvin, and
Yeah.
it's like in a diamond lattice.
Yeah.
Like, I mean,
And you got to connect all those things.
write and read to them. It's a fun problem. But if you do it perfectly, you only need 267 to calculate 3.28 times 10 to the 80th. Which is crazy. I mean, to put that in context of like day-to-day stuff in terms of code breaking, it's very real numbers, right? That's
I think that's how people got scared at first and said we need to invest in this. There was a Shor's algorithm that said you can do quantum encryption, break any RSA code. And like, oh, that's not good. You could freaking break the internet with this thing.
So how scared are you, like knowing what you know now?
With quantum computing?
Yeah, in terms of like espionage and code breaking, and like how realistic is this to solving the problem?
I'm not really scared at this point. I don't know, maybe 10 years from now. But it's a super hard problem. So it's going to take a lot of smart minds to figure that thing out. So I'm not too worried.
I mean, there's a materials limitation, there's a measurement limitation, there's a lot of things that have to be learned and understood.
Yeah, and I don't know if anyone's really figured out how to use it yet. It's claimed you can solve quantum chemistry problems with these things. It scales well, but still, it's early days.
Texan Space Agency. When will quantum computing be applied to online dating?
That's when we've made it.
Like, you make jokes about that, but like a lot of the early internet was driven by porn, right? Like transferring images, transferring video, like innovations in compression and digital processing.
It's that, and I mean the gaming industry, and all the computational power. Yeah.
The video cards, and I mean, necessity. That's necessity drives all that forward. GPS, the wonder of our time, and now its most used function is to find someone to have sex with. Write a paper on that study. I don't think that's the exclusive use of GPS, or the most prevalent use, but I appreciate the sentiment. To be fair, I mean, sex and reproduction has driven most of human endeavors for, 500,000 years. Okay, yeah. It's not unreasonable to say that drives current technology. Quantum computing. See, should be writing proposals to like Pornhub. See what they'll fund. They'll pay more than 30,000. Not as cheap as Major League Baseball. That's amazing. Online dating. I'm sure there's some fractal analysis. How else would I know about single mature women in my area looking for fun? Here at Ask a Scientist Gaming, we talk about the important topics. Thank you, Texan. I appreciate it. Man, that's a fun sociology, psychology / information processing problem. And I've read about this recently. There used to be a dating app that tried to connect people on things they similarly hated. So like OkCupid and stuff tries to find, cultural, social, religious overlapping Venn diagrams. There was one that tried to do it on things people hate, and it just failed miserably. Because it turns out you can't spend a lot of time conversing with each other on the stuff you hate. Like you have to have overlapping, appreciation of things, or it's going to fail.
Interesting.
Get this man a Pulitzer for asking the hard questions. No, the Pulitzer is if you answer the hard questions. Asking is not enough. You have to answer. this keep score? How does it? I don't remember.
Oh yeah, there's a score up there because I was hitting these high scores.
It's
Almost, but I guess if you advance a screen.
there's things you jump over.
Oh, I see. Because I started just running through these logs because I noticed I didn't lose a life, but I lose points.
Huh. And this is back in the day
When you're paying attention.
So when your kids started playing video games, like we're discussing now, there's a recent study that came out that basically said for brain development, video games are better than social media or passive TV watching. So like when your kids started playing video games, what did they start with? What age was that?
Gosh.
Been a while.
I don't know. Elementary school, maybe? Elementary, middle school. I mean, the first ones I remember them playing were Minecraft. And they got hooked on that, and then I tried to get them to get the quantum module. So you could have blocks that were being a superposition state, or they'd be entangled with blocks far away. You could do crazy stuff, but they didn't get into it.
Yeah.
Probably because I told them it would be cool to do.
Yeah. You're dad. That's fun. Have you seen people build computers in Minecraft? Have you watched any of those YouTube videos?
No.
They've done complex calculations and logarithmic calculators.
Really?
Yeah, actually executing. Because, I mean, you can essentially generate a switch. So
Okay.
you just sheer attrition, you can generate basically a computer. They have things that generate visual imagery. It's worth a dive in YouTube videos. It's amazing what they've done. I didn't even know there was quantum.
Yeah.
You could, because you could simulate a quantum computer then theoretically in Minecraft.
Oh, that would be cool. Yeah, there was a couple of ninth graders contact me. They want to learn quantum computing. So maybe I should tell them to build one in Minecraft.
Minecraft?
I would be impressed.
It's applied learning. You just got a random cold call from...
One sent me an email, yeah, from a local school. And then another student contacted me through MagLab. Wanted to do a summer intern.
That's fun.
Two different schools in town. I said, hey, why don't we get together and, it'll be two students so you guys can work together and I'll introduce you. They knew each other.
That's awesome.
Yeah.
$267 Cubans. Where's totally not Eugene? You need a double check on that. He came back.
He would know.
It was like a conference or a workshop on quantum computing, and he just came back so jaded on. He's like, "This is never going to work. The things you need to make this happen."
Oh yeah, I don't think you were at that workshop at the Mag Lab. It was on to kick off this Quantum Institute, and I had to talk right after him.
And everything.
Well, yeah, I had set this thing up. I knew he was going to talk before me, so I thought, oh yeah, we can kind of, I can talk about how we can collaborate on some of the stuff he's doing on advanced computations, and then man, he just starts trashing quantum computing. And then I got to get up and I showed that we could integrate cosine squared on an IBM quantum computer. No one's done it, but no one was quite impressed. We reduced the error on it doing some stuff, but you could do that calculation pretty quickly on a standard machine.
Yeah.
So that's why I'm not too worried about quantum computers controlling my brain anytime soon or shutting down the internet.
You and Eugene both. That's a tough act to follow, though. Somebody just shits on the entire field. The Texan Space Agency wants to know, Dr. Oates, do you do any making or crafting? So to put context on this, Texan is actually a streamer. He streams like metalwork. He does
Oh, cool.
blacksmithing on stream. He actually shows working and generating things.
Mm-hmm.
So yeah, presumably that's context. And he says, surely you've hunkered down and built a potato gun. Mechanical engineering skills apply.
Oh man, I haven't built a potato gun. I mean, we do some 3D printing in the lab, but that's just polymers. I have a collection of old cars. So I have an old 78 Land Cruiser, and rebuilt the manifold a few weekends ago. So I'll tear that thing down and rebuild parts on it. So
Well, that's fun. You actively keep up on your car maintenance.
yeah, like I mentioned, my dad's still alive. He lives up the road in Cairo, like 30 miles from here.
Oh, nice.
So he's retired, and mechanics, they have to have all their own tools.
Yeah.
So he's got every tool known to man. So I'll go by there and play around with some stuff. So that's always fun. Get your car back up and running. 'Cause I have to take my youngest to school. He's like, Dad, this thing, it's diesel too. So the thing, it's like driving a tractor with a cab on it.
Yep.
So it's already loud, and then your exhaust manifold goes out on you. He's like, what is that diesel smell? It's like, just roll the window down. I gotta work on that.
So do you fix your like modern cars, or you just the classic?
No.
They're too complex.
So I still have the car I drove through high school. My parents bought it brand new in 1972, 72 Impala.
Wow.
So I've still got that and the 78 Land Cruiser. That's it. The rest of the family's got vehicles with air conditioning, electronics. But they can't fix any of it.
Texan, do your projects cards run currently and you're that old? It wasn't new. When you were born, that was...
I was probably conceived in that 72 Impala.
Yeah, I was going to say, a timeline pretty close.
Yeah, I was born in 74.
It's got backstory. You have to keep it alive.
Yeah.
I like it. Are you good on beer? Do you need another one?
I'll take one. Sure, I'll try the other one.
I'll be right back.
Man, I'm an engineer.
You keep one on your keychain? Awesome.
Yeah, I just have this thing with me.
We're switching it up.
Whoops.
All my guests what they want to drink, and Billy was like, I want to do a Hefeweizen. And listed a couple that don't get delivered here anymore.
Yeah, I haven't seen Paul in there forever. Every once in a while I'll see Edinger at what's the place down on Benton and Thomasville. There's a beer store down there. It's right beside. So there's the beer store, and then there's the medical marijuana, and then I think there's a lawyer courthouse. It's all right there.
There. All right, we're trying Einger, another German Hefeweizen. A Brassweizen.
Yeah.
And do you have a P.O. box? I need to send you a handmade bottle opener. Ooh, Ask a Scientist bottle opener. I like it. Man, I am jealous of the skill set of being able to like work with and process metal. Like, because we 3D print stuff, but that only takes you so far. And Texan it's a really cool setup. He has like 3 cameras with the lighting systems, and you can see this blacksmithing work, which is pretty cool.
Yeah, that's something I wish I knew how to do more of. It's welding and blacksmithing.
Yeah. I mean, it's one of, like you said, with the car, you have to have the tool set. Like there's a barrier to getting even started.
Yeah, especially with older stuff. It's often hard to find those parts.
All right, are you done with Pitfall? You want to try something else?
I'm done with.
You want Cubers or Super Mario Brothers?
Oh, we haven't tried Super Mario.
Go back to the original.
Fired up.
All right, let's do it, ladies and gentlemen. We are going old school. Well, all of it's old school, but this was one of the first.
Man.
So this is one of my favorites. So Eugene and I, it's got to be about 5 years, 3 years ago now, we started a competition between each other to speedrun this game. It all comes back to speedrunning. But in your bio, you said you were the best on the block at this game.
Yeah, I used to invest some time in this one.
No pressure.
Never did the speedrunning thing though.
And it didn't start until like early 2000s was when speedrunning started to really take off. It was because basically people could start taking videos and posting them. Because anyone can make up a number until you can actually prove you did it.
Yeah.
Texan has some advice. An anvil goes for about $7 to $10 a pound. It's not too bad. It's a standard anvil. 100 pounds?
Yeah. Maybe.
That you need a welding torch, some sort of heating furnace. 131 pounds for Texan's anvil.
Hey, one of the cool things we did at Georgia Tech, they have this Ramblin' Wreck Parade. So you have to design and drive a vehicle during the homecoming parade that's indirect drive. It can't be engine, transmission, differential. It's be some indirect thing. And so, these fraternities, they'll be out back building these things late at night after some beers. And you have the acetylene torch out there. And, there was sometimes they would fill up this, we had a basketball goal with a hole in the bottom. They would fill that thing up with acetylene and then light it. Man, it's pretty good fireworks.
Drug college kids experimenting.
There was another team that they had a pretty cool idea. They had this flywheel. They built. They just took a tire and filled it with cement, and then they would hook this thing up to engine transmission and rev it up, and then they had a clutch, and the thing would engage the clutch and drive the vehicle forward, and it'd slow down and they'd rev it up again. Well, they were fixing this thing up one evening, and of course they're also out there drinking beer and stuff, and they're welding stuff, but you got an engine, you got a fuel tank, they're moving all this stuff around, and at some point the whole thing catches on fire. Like, oh shit, somebody get over there. And we help them put it out, and I think it was less than 30 minutes later they've got this thing up and running again. It's crazy.
Do they still do that?
Maybe. I haven't followed in a while. I mean, before I got there, they get in trouble because the kids are usually up all night trying to fine-tune this thing, make sure it's going to work for the parade.
Yeah.
So this is like a football homecoming. So you get a bunch of people out there at downtown Atlanta, and someone had some kind of thing set up where it was like they were sitting up tall away from the vehicle, so it had this huge steering column. It had all this slop in it. And they decided instead of having the parade go straight, you had to take a 90-degree corner. And no one was hurt that I remember, but this thing just goes into the crowd.
It's a non-zero race.
Oh, man. But the one we did, there was some guy that he had a Toyota Celica and he couldn't get it up and running. Industrial engineers, he didn't know anything about gears and stuff, but it was a timing belt that went out, and so
brutal.
It was a pain because you had to pull a bunch of stuff out, radiator and all this stuff, but you just had to get a $10 timing belt, and then the thing run like a champ. So we put this on the back of a tore down U-Haul and got an extra differential and hooked it to the Celica back wheels. There was a differential with we found we went somewhere and found a big fire hose and wrapped it up, duct taped it, and hooked up the differential to this. And then the mounted differential went back to the wheels on the U-Haul. So you had this Celica on the back of a U-Haul with two different differentials, and we ran that thing through the parade. It was the only one that would go forward and backward, and I kept worrying.
So advanced.
I kept worrying that this fire hose was going to run off the hub of the tires, but it made it just to the end, and then the whole thing just disintegrated. And we won the whole thing with that thing. It was awesome.
How was the winner decided?
Well, part was performance. So, and also just there weren't too many that finished.
Yeah.
So we finished. Thing would go forward and backward, and yeah, that was pretty much it. I think creativity was in there too, but
so there was a panel of judges.
Yeah, I mean there was. So we stopped right in front of the panel, and I got the thing to go reverse. Seemed to be impressed. The next year after that, though, I tried to do something more advanced. We took the same U-Haul, but then I found this cam and got these ginormous springs, and you can put my dad had like a 2-inch size socket. It's just this ginormous socket, and we put it on the transmission, so it was like an accordion. Springs would go back and forth, and then the drive shaft would ratchet forward, and then it would lock and go forward. That thing made it about halfway, and then the springs weld shot, and they broke.
Texas' favorite quote of the night. And then we backed up, and the crowd went wild. One of our canned questions, Bo, or what was your peak achievement in life? We already know your answer. When it backed up.
Yeah, that Ramblin' Wreck Parade, man.
It's funny, but those are the ones you remember. Like, it wasn't the test that you aced or anything like that. Like, just weird. It's an achievement.
Oh, so the funny one was when they selected me to be the chair of the department.
Oh, God.
And
Billy's chair of mechanical engineering right now as we speak.
Yeah.
While he plays Mario.
And I think I had to at least present. So it was one other person considering doing it. And I said one of my big achievements was started in high school. And so I don't know about your high school, but everyone, you get to vote on your peers on who's going to be most successful, most intellectual, most photogenic,
and categories that are no longer socially acceptable.
Probably some of those.
Yeah.
Most athletic.
Yep.
Well, I got most dependable. And I mean,
you said that at your pitch.
Yeah. And if it would have been social media these days, my phone would have been blowing up with girls wanting to date me. Most dependable.
Most dependable. I mean, man, to be fair, when you have a chair, it's like, who's going to be consistent and fair? Who's going to respond to emails? Like, the skill set is very, Did the other person actually want to be chair, or was it just an obligatory?
I thought they were done, and if I knew they wanted to be it, I'd be chair. I think it was like a last minute thing.
Now I remember my second year here at FSU, and the chair position came up, and it was for voting and whatnot. Mm-hmm. And they usually put 3 people on the plate, right? And that's what the canvassing committee does, is find 3 people that are willing to do it. Mm-hmm. One of the person went up, and they were like, I'm intrigued, but I don't really want this position. Like, if you voted for me, here's what I might do if I got it, but I don't want this job.
Yeah. Sounds about right.
Yeah. I mean, it's the people that want it it's like any politics, right? The people that want it are not the ones you want.
Yeah. Yeah.
So. All right. What was that jump? Talking shit about your gameplay in chat here, Billy. No worries. All right, I'm going to run to the restroom. In the meantime, I'm going to give you one of our standard questions. What's your favorite equation and why?
Oh, yeah. I think I wrote this one down, in case I forget. So, all right. It's getting late. Let me make sure I've got this one right. Here's my cheat sheet. Oh, yeah. Euler's identity. So I'm sure some of you remember this one from mathematics, but basically Euler's identity got me through my PhD. So using complex numbers, if you remember, e to the I pi equals combination of now I need Ken's help to help me remind. It's a combination of cosines and sines and imaginary numbers. But ultimately, I ended up using that to get my PhD. So I said the best equation out there is Euler's identity.
You are the third guest that has said that. No joke. Your friends did. Who else did?
Yeah, it's hard to beat that one.
Yeah, apparently it's universally applied.
Yeah. I basically used it through the PhD for elasticity and solving problems in using complex numbers.
Huh.
There's this thing called the Cauchy-Riemann condition, which allows you to solve Laplace's equation using analytic functions. Man, that thing saved me.
Mildly related, how'd you get a postdoc in mathematics, given your degree? How did that
Yeah, so working in the field of smart materials. So I guess my PhD was kind of pretty much 50-50 experimental and theoretical solid mechanics.
I see.
But on ferroelectric ceramics, and there was a guy at NC State I knew just through the community, and he worked in the same general area of smart materials, but a little bit more broad, doing some stuff in nonlinear control and modeling. And so he...
Oh, no.
That's not right.
Hitbox.
So he worked in the same general field, but in the math department. But did a lot of applied math. So ended up working for him for a couple of years. And it was fun. I mean, it was in applied math, but we took some of the mathematical relations in control and put them on some experimental hardware.
I see.
So I think he wanted someone that could kind of bridge those sides.
Well, that makes sense. I mean, you both got something out of it.
Yeah.
New area of expertise.
Yeah, it was great for me. So if there's folks out there thinking about, what to do after PhD, it's good to go do something a little different.
I mean, so how common is a postdoc in engineering?
I think it's a little harder because it's hard to compete with salaries, once you get your PhD. You usually don't do a PhD unless you're really, postdoc, unless you're really interested in academia.
Mm-hmm.
And I don't know if it's started to change, but when I was applying, you were competing with like 200 or 300 applicants. The most recent ones we've been searching for, we haven't been getting as many applicants. don't know if it's because we're making the call more specific. So anyway, it may be on the order of like 50 or so.
Oh wow. And I guess that's not, if we do a specific call for like analytical or measurement, that's we'll get 50 to 100.
Yeah.
Something like that.
Yeah.
Yeah, we generally in chemistry, we don't do a heart rate in chemistry, we try to specify something.
Yeah, that takes a lot of work to get through so many.
It does. And the energy and materials, you were part of that. That is such a beast. That was like 500 applicants or something ridiculous.
Yeah.
How did you guys even do that? So those of you not familiar, I was hired through something called an Energy and Materials Initiative. So I wasn't hired in chemistry. I was hired as part of a like university-wide, we're going to go after this area. And Billy was part of the search process, actually. So I get insider information after the fact. It was a general call across chemistry, physics, mechanical, whatever, engineering, material science, computer science. It was everything, right?
Yeah, we tried to have some overlap. We didn't review every single one. We tried to get into smaller groups, and there'd be some overlap to get enough, cross-pollination on thoughts on things. Otherwise, you just couldn't do it.
So many applications.
Yeah.
Like, it's so much to read, and
yeah,
I don't know. So on the other side of it, I'm amazed any of us get hired for anything, because it's roll the dice, luck of the draw, plus timing, plus luck, plus it's crazy. All right, we're at 10:15 now, so anyone just joining us, Ask a Scientist Gaming, mediocre gameplay, expert level science. Billy Oates is playing some Mario Brothers, but also answering questions about smart materials, modeling of systems, fractal modeling, uncertainty analysis. He's happy to answer any questions you guys might have related to anything mechanical engineering or otherwise. We are happy to discuss it. What I like about Ask a Scientist is we've gone on a journey through many topics, from like dating apps to hobbies of welding and blacksmithing to, it's a lot of fun. I just want to swing a hammer. Don't we all? I can fully relate to that. It's been more of an exposure than a journey. We learn a lot about ourselves during this stream. Oh, did you remember that, pipe, or you were just trying random?
Oh, I've been trying a few before that. I knew it was coming up.
Okay.
I kind of remembered it.
Before we switch over to NARC, I got to show you some of the stuff they figured out speedrunning this game, because, I mean, you do some programming, so you'll appreciate just how well they know this.
Isn't there, like, some kind of crazy hacks on some parts of this?
So the speedrun now it's basically within 2 frames of a computer-executed perfect run. So they've done basically 5 minutes of perfect Mario, minus 2 frames of mistakes. It's absolutely crazy. Oh, did you ask the movie question? No, I haven't. Texan, do you want to deliver it, or should I just go now? It's a good question. It's one of my favorites.
Is that the one that they got right or didn't get?
So for those of you that don't know, spoilers, I give all my guests the planned questions ahead of time, just in case chat gets slow. We have our plug standard questions. The one I really like is related to movies. So I've watched a lot of movies. I love movies, but I also love those moments in movies where you're like, this is absolutely absurd and shouldn't exist, and others where it's like they did their homework. So the question is, are there any movies or TV shows that get your discipline or expertise right, and which ones get it wrong?
So I had one queued up, but then I went and watched the second Top Gun.
Oh, you did?
So I don't know if this will be a spoiler.
Oh, I haven't seen it yet.
So this isn't a huge spoiler. This is something that happened at the beginning. So just be aware.
Yeah. Who's dies? Too soon.
So at the beginning, they're about to lose their funding on this hypersonic program, and he's gonna of course, they come in and tell him, and then it's like, okay, well, I'm going to fix this. It's like they're going to have they don't need these piloted systems. They're just going to have drones run this thing up to hypersonic Mach 10. It's like, oh, well, I can fly this thing at Mach 10. And so he gets in and flies it. And then, of course, they tell him, like, okay, just go Mach 10, not 10.2. And you know what Maverick's going to do.
Yeah.
So the thing overheats. And like, oh crap, we're 10 minutes in the movie, he's already dead. So he shows up at some random bar in his suit, and people are thinking he's like some kind of alien. And so ejecting at Mach 10 is not something I advise to do.
You know, physics and all.
Probably not going to survive that. So yeah. That was one.
That's a lot of bowling balls.
Yeah.
With the force.
Yeah. For real. For
oh
real.
my god.
So.
Like that's tear your lungs and organs apart inside.
Yeah.
Oh my god.
Yeah. The other one that you could imagine, Transformers, is I do some work in robotics and of course smart materials. We're not quite there yet. So we've got a long way to go.
Can we get there though? It's Transformers on our horizon.
Yeah, I don't know why not. It's just engineering, so I think you could do it with enough knowledge. I
mean, correct me if I'm wrong, but one of the fundamental limitations with like jetpacks or robotics is just the power supply, right? That the mass density.
I was about to say you're gonna have to. We'd have to run some numbers on the energy density. Mm-hmm. Yeah, because the folks I do know that they do a lot of, they're experts in legged robotic systems and limb systems, and if you talk to anybody in biology, they'd be the ones to ask on scaling laws. On when you go from insects, which can carry crazy kind of weights, to elephants and dynamic mobility. So, yeah, that's another one. Can you find the materials that are strong enough to handle those dynamic loads?
Yeah.
Plus the energy? I don't know. That may be a limit.
One of my favorite factoids, related topic in terms of like comparing bugs and things to other, like you will never have a 50-foot cockroach. And the reason is they don't have a circulatory system, right? There's a surface area to volume ratio because they have to absorb through the skin. And so there are fundamental physical limitations that, like you said, it's energy density, it's mass versus volume ratios. It's a really fun calculation, a fundamental exercise. Yeah,
I'm sure there's a movie out there. 10-foot cockroaches.
Unrealistic, the tarantulas. I mean, that was like every movie in the 1940s, right? Yeah. 1950s. All right, so your unrealistic movie was Top Gun, and then realistic movie. Who gets things right? Yeah,
I mean, it's Apollo 13, it's obvious one,
fun. Yeah.
We know that they make it back. So that's
spoilers.
The NASA stuff, the more recent Hidden Figures is another good one.
Oh, that's fun.
So
yeah.
Those are the main ones I can think of. I don't think of anything science fiction related otherwise.
I mean, the thing about science fiction, and I've thought about this a lot watching movies, is as long as you can accept like one premise that they've just said, entropy doesn't exist, therefore this is okay. Like if they don't try to bullshit around it, they just accept like this is one axiom. If it's acceptable, all this makes sense. I'm okay with that.
Oh yeah.
It's when they try to go beyond that. I don't know.
Yeah, if it's not consistent to the story.
I think that's it. Internal consistency is probably the biggest issue. And the answer is What's eating Gilbert Grape gets it right. Mean Girls gets it wrong. Thank you, Texan, as always. Classic.
I mean, I watched that movie Tenet a while back, and I still cannot figure out that thing.
I have
The
not
thing
seen
about
that
time
yet.
travel.
I heard it was terrible.
Yeah,
Or not
I mean,
terrible, just not good.
It seemed like it could have been so much better. This thing about time travel and thing of that, but I couldn't follow it. And,
Mechanical engineer, PhD, department chair, mathematician Billy Oates could not handle that movie.
no, well, it turns out my wife is usually helps explain these movies to me, and she couldn't explain this one, so it was bad.
Yeah. No, that's terrible.
The best one. So I don't even know if I can remember this full factoid, but I got pulled into consciousness and trying to make sense of if this is something interesting to study. And so Roger Penrose has got an old book. I don't know if you've read that one on. I think it's called The Emperor's New Mind. It's a pretty popular one out there. But anyway, he goes through the full description of things like quantum mechanics, thermodynamics, classic physics, general relativity. He just goes through the whole deal before he gets to brain and consciousness and all that. He never solves that, but there was a part in there about time reversal that was interesting. And it comes back to this thing on quantum computing and how we're going to be able to use that, because you got all these different states, but then it collapses. And I think, again, I'm not a physicist, but I think none of the physicists or anyone knows what happens when the wave function collapses. And he had this interesting description in his book that you'd probably appreciate, because it was it's related to photons. He said if you take a mirror at 45 degrees in this tube, absorbing walls in the tube, and the mirror will is 50% absorption of the photon. So probability, half photons go through, half will reflect and hit the wall. And then you got a photon detector at the other end. And you can detect if these photons come out of the lamp, and then say you can control it where just one photon comes out. And so he does this thought experiment, and he says this, and then he says, okay, well, quantum wave functions 1 over square root of 2, because the probability is 50% it goes through. And so you can predict this, half the photons will go through and hit the photo detector. And so that's forward in time. And then he says, okay, what if you go the other way, reverse it? And he says, now you know that you're at the photon detector. Oh man. You're at the photon detector, and you sense a photon hits the detector, and now you take it back in time. It says, given that situation that a photon hit the detector, what's the probability that it come from the lamp? It's like, once you take that measurement and collapse the wave function, it's irreversible.
Yeah.
So wave function is not time reversible.
That's a fun thought experiment.
So yeah, it's a great example.
I mean, I love that the Einstein and exchanges, the Schrodinger's cat, and, like, because you extrapolate the thought experiment as far as you can, and it just breaks reality.
Yeah.
It bends your mind.
Yeah.
All right, we're at 10:30. Can I show you something cool they figured out in this game?
Oh yeah.
It's just for fun. I'm going to show you this. So do you remember the warps where you go like a bunch of different levels? So on 4-2, there's a vine you can take. So that vine takes you to World 8.
Oh, I forgot about those things.
Can you remember that? So like you go up here and you go to World 8. Well, what these guys figured out is that takes time. Climbing that vine takes a bunch of time. And so they figured out, okay, there's another warp in this level. I'll show you where this is. Oh, too far. So you go to this tube. It takes you down the tube. It takes you to the underworld. What these guys figured out is if you jump backwards into the wall... I screwed it up already. Do this again. They basically, the way it picks where you go, whether it's up the vine or in the tube, it's dependent on where Mario is on the screen. So it's not absolutely programmed in. It's not that the vine always takes you up or the tube always takes you down. It depends where Mario is on the screen. So if you jump into walls backwards, it shifts his positioning on the screen. So we'll see if I got it right. So you can basically trick this tube into taking you up the vine. And so the vine animation doesn't go, you just appear up there. And so you warp to this, and it saves you 1.5 seconds. So by jumping backwards into walls, you can save 1.5 seconds by going forward directly. And they figured this out by deconstructing. Absolutely insane. But it's that's why I love speedrunning, because they know every it's scientific method, right? You know the rules that govern the system, and you control it to your whim. But anyway, it's 10:30. I think it's time. Are you ready for some NARC?
Yeah.
So, cheats, Texas Space Agency cheats. I mean, it depends how you define cheats. I mean, it's within the parameters of the code, right? You're not injecting anything new. You're just manipulating what exists. All right, Billy, so are you ready for a NARC? This is our Ask a Scientist Gaming Classic.
Yeah.
You're going to win the war on drugs tonight. It's just a question of how long it takes you. We have a little clock that we like to keep track of. You're competing against all your peers at FSU that have been on Ask a Scientist Gaming.
Yeah.
So go
destroyed.
Pull the trigger. Let's do this. So the basic rules are walk right and go through doors. That's pretty much your goal in this game. The one thing I like about introducing a random game to the stream is that there's no pressure. You've never played this before, right? It doesn't matter how good you do. But yeah, this is NARC, ladies and gentlemen. If you haven't seen this game, this was written by Nancy Reagan in the 80s to win the war on drugs. Don't quote me on that. That's not actually true. But yeah, this is another exemplary manifestation of our loss in the war on drugs. It's like $3 trillion or something. But anyway.
Yeah, you mentioned I got to go on these DARPA trips.
Yeah.
One of them was to there's a base out in Key West. So I thought, oh yeah, I can go to Key West. Awesome. And so they do all the trafficking of drugs and human trafficking out there. Mm-hmm. And so out front, they had this, they called it Bigfoot. It was like a 20-foot sailboat that they had chopped the top off of it and sealed it up. And it was like a partially submersible submarine. It had a diesel engine in it, no latrine, but you could carry 2 tons of cocaine in it.
It's engineering at its finest.
And so that's oh man, how to get in that door?
This is a card.
Oh,
there you go.
Oh man, they're killing me. Yeah, so I had no idea how hard it would be to find see these boats. I mean, part of it was above water, but they'd get some idea that these things were out there, and they'd say, yeah, there's a partially submarine out there, and they would get out there with their helicopter, but couldn't see it in the water. It wasn't until the helicopter blew the top off, the tarp off the top, that you'd see it. So they finally found one. They called it Bigfoot, and they had it out front of this Joint Strike facility. Can I get in there? No?
Keep going. There's the door at the
Oh,
end.
this one.
Not all the doors are
Helicopters.
acceptable. And people throwing syringes at you. You went through DARE program, right? It's based on a true story.
Yeah.
Can you believe three decades later, they're still doing DARE in schools, despite like all the evidence saying it's not useful and it's counterproductive?
I don't know, man. I remember some of those videos they showed in the 80s, this girl doing like PCP, and then she'd jump out the window and she would just take the glass and cut her wrist with it.
Yeah.
It scared me.
No, it was terrifying. So the mistake they did, at least my current understanding of it, is that the problem with DARE is that they treated all drugs like equally. Like marijuana is going to cause you to jump out a window on PCP. And then somebody like tries marijuana at a party and they're like, well, marijuana wasn't bad. PCP is probably okay.
Yeah.
That has been my experience with PCP. Text, we're glad you could join us in chat despite jumping out a window. Oh, man. Oh, PCP, classic. So this, you have to get a blue card, and it's going to drop out of one of these black guys when you shoot them at close range. There it is. That's it. So that's they call it in speedrunning, they call it RNG. It's a random number generator moment. And there's a certain probability that they will drop the card or not. And at some point when you've optimized the game enough, it comes down to like, if it's a 1 in 10 chance, you have to run this 10 times for that to work correctly to execute the rest of the game. I tried pot one time, and the next thing you know, you're listening to jazz music and fornicating. Reefer Madness is a classic. I don't know if you've ever seen that in one of the like really early anti-drug movies. Absolute absurdity. It's amazing. Reefer Madness. All right. I'm going to ask some of our more canned questions because I like the answers to these. And you had the list ahead of time, so hopefully it won't catch you off guard. What's the flat Earth or anti-vax equivalent in your field?
Oh, yeah, that's a good one. I mean, it's kind of harder with...
You can jump in the car.
Can I?
Yep. Tap B. There you go.
Oh.
You're going to smash it right away, but it's okay.
Oh, perfect.
There's a path you have to memorize, and I apologize. But anyway, flat Earth anti-vax equivalent. What's the Facebook mechanical engineering, smart materials people getting wrong?
I would say a lot of people say they'll fit a model to some data and say they can predict stuff. That one happens a lot.
Yeah. Interpolation versus extrapolation.
Yeah. I think you see a lot of that, especially in, well, some in machine learning, but even in physical models. You take some data and they're like, oh yeah, this model fits the data well. Yeah. I mean, a model's purpose is to predict stuff you haven't tested. And sometimes you don't see that. So that's one main one. I say the other, just in general, for being department chair.
So you got to jump over that department chair experience.
I may get in trouble for this, but
no worries. Nobody's gonna watch it. There's literally dozens of people watching.
I would say, how do I jump over this thing?
Tap B. So there you go.
Oh wow, that was nice. I would say ego gets a lot of people in trouble. You can drop your ego, man, and you can do so much. So that's my biggest pet peeves.
I mean, and that's what's crazy in academia. It selects for those people too. Mm-hmm. Like we all have egos. That's fine, but the density in an academic program. This is something really weird because we have this like obsession. I mean, especially like even in the university like ranking system, the number of people you put in academia is favorable in that ranking system. But academia is treated as like the pinnacle of achievement in science. That's just not the case, right? If you go to industry national labs, you can still do amazing things.
Yeah.
It's just we self-aggrandize our discipline. I don't know if that's historic or what causes that.
I don't know.
But like, we get paid less, we have less resources to pursue research. I mean, it was very different hundreds of years ago than it is now. It's weird.
Yeah, I guess you gotta sell your research. That gets conflicted with, talking about when you're wrong, what you can do to fix it.
Yeah,
That doesn't get rewarded.
no, that's true. You can't publish failed results despite them being useful for somebody, right?
Yeah.
So if you go along the bottom, you'll have more time in the car this time.
Okay.
So I'll give that hint away.
I can just get in the thing.
Yeah, 4 frames on the tab. That is your time window. So it's this operates at 60 hertz, so you can do the math from there.
I can run it too.
So is this game everything you hoped it would be?
Man, I need some bullets. Can I
Yeah,
punch?
you should. Yeah. No, you can't punch. You can bullet or you can rocket. Or run away because he's slow. It's totally up to you. You have nothing to prove here. I'll respect you
Obviously.
That's why I like closing the night with night, because just who cares? Like,
Yeah, I've never played this one.
yeah. So this was one that it was actually an arcade game. So like this would show up in Pizza Hut and bars and whatnot. And it's super violent and aggressive, and they ported it to NES. They toned down the violence, the number of hookers, and all sorts of stuff. So if you go along the bottom, you'll avoid a lot of things this time.
Okay.
But yeah, it should translate perfectly to Nintendo. The 8-bit system could not process this as well as the arcade could. But,
And then we got Grand Theft Auto.
yeah, exactly.
Just threw that out the window.
Yeah. Then for, 3 decades, people blamed video games for school shootings when all the research says otherwise. Yeah. It's probably too soon for that discussion.
Yeah.
But that's frustrating. I just want evidence-based decisions. Is that too much to ask? But now you get the clowns with knives. Heads up.
Oh, cars too.
All right, so one of the other questions we like to ask, one of our go-tos beside the movie question is, unlimited budget and no moral qualms, what experiment would you do? And so to give you context, we have people that want to put a tracking inklet on someone and send a hurricane at a city and see what people disperse.
Oh, that's a good one.
We want, reproduction of twins and separating them at birth. We're shoot for the skies here. Like you build a lab on space, like on the moon. It's totally up to you.
So, there's this thing called, I forget the exact name, but it's something like transcranial electromagnetic stimulation.
Yeah, it's
So I
easy
heard
for like
this.
Parkinson's.
Yeah,
Yep.
well, I heard about it. There was a great podcast on Radio Lab.
You gotta stop pressing up when you go through the door. It's happened.
I ended up. So there was a podcast on Radio Lab where I don't know if you heard this. Jeez.
Sorry.
This reporter heard about, I think, some researcher out on the West Coast doing some of this, and she flew all the way over from Europe somewhere to do this thing, and they.
Nope.
Where the hell did I go?
So go out the door, but don't go back.
Man, those are aggressive clowns. Like, yeah.
Don't you remember that from there? The clowns with knives. So don't go through. Yep. That one. Yep. There you go. Anyway, sorry I interrupted.
Yeah. So. Oh yeah. So they set her up to do this transcranial transduction, but they first had her play a video game, kind of like this one. It was like some active shooter game, and she gets destroyed. Right? She's never played this game. She's flown over, jet lag, and then they do this transcranial stimulation. And she comes in like she's some freaking Navy SEAL. And she's like, it's like she just destroys everything, and it's like time is just standing still. And so then they go through this whole story on how people are doing this, and some people are doing DIY hacking this, and those cases don't go too well. But it is interesting that in some cases then it just really works well.
Yeah.
Where am I going?
Grab that thing. There's a card that fell right on it.
Okay, I thought I was gonna explode.
So some of the marijuana plants explode, others give you money. I don't write the rules of NARC. You can see why we closed the night with this after a couple beers.
Yeah.
So transcranial, you want to dive into that area.
Mm-hmm. Yeah, that and consciousness. These ideas Penrose has had on collapsing the wave function, and these ideas of these microtubules inside the neurons apparently is where supposedly he says that consciousness happens when these things collapse somehow.
Emergence.
Figuring out some of those things could because no one has an answer what consciousness really even is or how it works. So I think that would answer some interesting questions.
I mean, it's one of those things, like we've talked about previously, the regression of the mean in funding for grants and research studies. Mm-hmm. Like, even if you wrote a really good proposal for this, people would be like, this is too far out there, right? We're never going to fund this. Like, it's not guaranteed results. It's not...
Yeah.
But I agree. It'd be really fun.
Yeah.
Yeah.
Yeah, we do seem to be more conservative.
Yeah. I mean, along that vein, if you, so I don't know if you've seen the movie Limitless, where there's a drug that enhances your brain function.
No.
I mean, it's one of those, like, if that drug existed, would you take that performance enhancing? And it depends on the cost, obviously, right?
Yeah.
This sounds like straight stoner talk. Yeah, man, consciousness, it's like microtubules, man. I'll tell you what, if they fully legalize marijuana in Florida, we will have after scientist gaming. Me and Billy will sit here and get high. Shit. Microtubules.
Yeah, I'm sure something good will come of this.
I mean, you'd be surprised the number of scientific discoveries that are the byproduct of drug use. No question. I mean, the DNA polymerase, that was PCP and driving down the highway. And I mean, half those drugs are accidental discoveries. Like, yeah. It goes hand in hand. I mean, the number of people that take LSD and have, like, life-affirming experiences, and, like,
hear about that
changes the way they experience.
Yeah, I think they're at least talking now about it not being so, whatever. People are, like, actually studying it to understand the brain now.
Which is awesome. I mean, it's especially a lot of the PTSD research right now. Things like ecstasy and LSD and how that treats the brain. Like, it was forbidden for so long. Like, if you make a drug class 1, I guess you can't research it, or it's very exclusive. Yeah. It really screwed up a lot of progress in understanding drugs.
I have heard about that, like, even for, like, marriage therapy.
Yeah.
Once we take it.
All right. So now you got to shoot the guy in the wheelchair with a rock. I didn't give Billy any warning about this, that he's shooting dogs in a wheelchair.
I'm going to be traumatized tonight.
Yeah, here's your PTSD, and you'll have to take magic mushrooms to deal with this. But tapping A gives you a rocket. If you hold A and B, you can shoot the dogs pretty easily. Oh, there you go.
Oh, I see.
Rocket.
Am I'm supposed to get my credit card.
Yeah, it's from shooting the wheelchair guy.
Okay. The guy's little.
So, Billy, full disclosure on this game, one of the reasons we play it is I'm the world's fastest NARC player. The world record in this game.
Holy crap.
And the reason it happened is I was playing this when I was the guest, because this was like the bargain bin game from my childhood. It was like a blockbuster when you had the $5 garbage game. This was it. And I played it as a kid, and then I got on stream and played it, and Eugene was hosting, and he was like, the speed run is this time, you will never beat it. Like, challenge accepted. So now there you go. I was going to inchworm 2 more times.
Oh my gosh.
Sorry, we're closing the night with this. I apologize to every guest. You didn't expect this.
Yeah, I mean, my thumbs are going to feel it tomorrow.
Yeah. This might awaken something in you, though. Like, I have to go back. I want to speedrun Mario. I'm going to do sub-pixel accuracy jumps, and I want to go as fast as I can. So you mentioned in your bio you did the Kinect, right? The Kinect Adventures. Is that what it was?
Oh yeah. My kids had that one. We used to play that one all the time.
Yeah, I really liked the Kinect.
Yeah,
it didn't last long, but the Adventures game, that was like the obstacle course one with the
that one was fun
and stuff. There was a horror game that was kind of fun. It was like you pick up weapons and you fight people.
Oh, okay.
That me and my wife did. I mean, we didn't have kids at the time, but I really want that to come back as something big.
Yeah, I know. I'm surprised more of that stuff didn't come out during COVID.
Texan, something has awakened. He'll pick up a drug habit and start shooting handicapped people with rockets. Billy, I take no responsibility.
Hey, I didn't sign any waiver. So you're on the
hook. Wow, nice. All right, that was 3. Now you got to pick up the gold card.
Okay, there we go. So
my major contribution to the speedrun is if you kill him off screen, he doesn't do the inchworm thing, and it saves you 15 seconds. So through sheer trial and error, I figured out
15 seconds.
Yep. And so now I hold the world record because of that. All right, here's the final boss of NARC.
That is legit, man. I won't stop.
I assumed you'd appreciate this. So if you go to the top of the screen, his tongues won't hit you. So that helps. But you got to run away. And what you have to do is jump and shoot him in the hat. And so this is non-trivial. So it's basically you have to do the tap B and tap A while you're in the air. Don't worry if you don't. Oh, never mind. You got it. All right, now rockets to the face. 2 of them and you'll go phase 2.
This is torture.
This is terrible. I'm impressed how fast you got that. Oh, there you go. Okay, so now it's going to be bullets on the spine. So what I do is come down here. Like, you can't shoot them up in this area. You have to be further down. Turn back and just hold A. Just bullets, yep. Then basically go back the other way, run far enough away, turn back and shoot. And then, so my brother actually deconstructed this game when I started speedrunning it. He's a computer and electrical engineer.
Yeah.
And he figured out it depends on your XY position as well as when you start firing, whether it hits this. It is a pain in the ass.
Am I hitting him?
Well, you are, but it's not the right timing. So what I do is change your position on the XY. Try again. Just try again. It is terrible.
So I got to get the.
Yeah. So move again. Sometimes it hits, sometimes it doesn't. We actually don't fully understand how this
works. I
works.
can't tell if I'm hitting him.
Yeah. So go this way, get far enough, move up somewhere.
I think that's doing something.
So you'll see when the vertebrae disappear and points show up.
Oh, so it starts getting shorter?
Yeah. So move up a little bit. Again, there's no official rules. But sometimes it hits, sometimes it doesn't. I'm sorry, Billy. I apologize for everything that's happening to you. So now you go back the other way and you try again. Like I have when I speedrun this, I have a very specific like place I go, and it works usually, but it doesn't work all the time. So there's no rules. This game, fractal analysis is necessary for this.
NARC, there's no rules.
Is it now? There are rules. So have you talked to anyone in like sociology or psychology? I mean, you have a set of data analysis. I mean, detouring back to our science.
Yeah, that's one I haven't done.
I mean, it's again, you have a skill set and a solution to a problem you don't necessarily know even exists yet.
Yeah.
Because like we have Sarah Hart who does a lot of the nature versus nurture, but she looks at major data sets of like test outcomes across all the schools and stuff like that. Like it's big data, it's big information processing.
Well, I did talk to Leslie Richardson. She runs the Florida Center for Advanced Teaching just yesterday, and we're going to try to get something going with them.
Oh, that's fun.
Enhance undergrad and hopefully train some of our grad students that actually learn how to be a teacher.
Which we don't train any of our students or our faculty to do.
Yeah. So I think that could be fun.
So for those of you that went to an R1 institution, which is basically a research-focused university, this is, the top 100 programs in the United States. We are all hired as researchers, and none of us have teaching experience beyond like basic TAing for a lab. And then they throw us in a classroom our first semester here, and they're like, "Here, teach a class, do it effectively." And it's absolutely insane when you think about it.
So after watching Top Gun, there's a Navy SEAL I listened to on podcast, and there was a guy that was a real Top Gun. He was on there, and he was saying, he went through that, and then he went back and was invited to be an instructor. He said, to be an instructor, when you come back, you're not allowed to talk to any of the pilots for a year, and they just teach you how to be a teacher for a whole year. So we don't do any of that.
No, we get zero training. Isn't it breathtaking?
But it is funny. We'll bring faculty in. We'll actually give them a break from teaching, get their research going. So I was thinking, if we're giving them a break from actually teaching, why don't they spend a little bit of that time working with some of these folks at FSU, learn how to teach?
Yeah. I mean, it's crazy too, and you'll talk to Leslie about this, but it's like we teach classes the way we did 100 years ago. And like we've learned so much about how the brain works, how knowledge is acquired, how information is processed. The skill set is very different now than 100 years ago. Like 100 years ago, we're in World War I, and we were, prioritizing manufacturing over
Socrates days.
Yeah, it really is. I don't want to belittle it because people worked hard to do that, but they didn't understand. Like they didn't know enough to actually do. Yeah,
and it's almost been like mass produced now, industrialized. Get a bunch of students in the classroom.
Yep.
To some degree you got to do that, but Leslie has some good ideas.
And it's kind of breathtaking. And I saw a really nice. Oh, there you go. You got one of them. So after all that,
man. That's what you had to do.
Keep going.
You just go up and down a little bit. I got it.
All right.
Man, that took a lot.
But it's really breathtaking because when you think about what our education system is, and there was a really great YouTube video on this that basically broke it down and said the way we put kids through school is based on their date of manufacture, right? Because it's based on students' age. This is when you enter the classroom. This is what you do at a certain age. And it's non-responsive. It's very like assembly line style, and it doesn't cater to the way people actually learn information. And it's crazy the way our education system works. Right. So you're hitting that door. 2710.
Is that like last place?
No, I think that puts you in the middle of the pack. We're probably saying top 15, maybe top 10. I'll send you an email where you actually are. So the world record is, what is it? It's 9 minutes and 24 seconds. So, yeah. But you can put your initials in. Fun factoid, if you put ass, you get double your score. Because that's the kind of game this is. I'll leave it up to you how you want to be remembered. Billy Oates goes in.
Whoops.
All right. That puts us at almost exactly 11 o'clock. So, congratulations, Billy. You won the war on drugs. Do you feel like you've accomplished something tonight?
Yeah, definitely. I'm much better about myself. Shooting the guy in the wheelchair.
And shooting dogs. I apologize. I should have given you the heads up on this one, but it's almost more fun to surprise you. Anyway, everyone, thank you for joining us. If you guys have suggestions on people we should raid, throw those in chat. I'll be happy to. Well, primarily we go after science, education-related streamers, but whatever. Throw your suggestions in chat. But it's been a pleasure, as usual. Ask a Scientist Gaming, mediocre gameplay, expert level science. Billy, thank you very much for joining me on
thanks
this.
For having me.
I send a random email to my colleagues and say, hey, do you want to play video games and talk science? And Billy said yes. We'll see tomorrow if he regrets that decision or not. But Billy, it's been a pleasure. It's been a lot of fun.
Same here.
We learned a lot along the way. Do you have any comments, any parting comments for the audience?
No, I don't think so. Pretty traumatic experience right here at the end. So I'm going to leave it there.
I mean, you won Tecmo Bowl. You won a game of Tecmo Bowl.
That is true. I come out at least winning one.
Yeah,
I'll take that.
R.B.I. baseball, I think you took the losses.
Yeah. But, ironically.
But Tecmo Bowl plus NARC, you took out the wins. Mario, you're doing pretty good. But again, thank you for joining me. This is a crazy ask, but it's been a lot of fun. I learned a lot along the way. So really appreciate it. For those of you that are following us, follow us on Twitch or on Twitter. Do notifications about guests. Our summer schedule is set, actually, so we're set through, I think, August 10th. We have the guests lined up, and so check it out on Twitter. We'll have that guest lineup. In 2 weeks, June 15th, we'll have Alex Robb, who is actually a recent PhD graduate from my research group. His graduation present was to be a guest on Ask a Scientist Gaming. So Alex is an expert at solar cells as well as photodetectors, converting light to electricity and signal processing. And also to be happy to talk about the graduate experience. So join us again in 2 weeks. June 15th, we'll be back again Wednesday night, 8 to 11 p.m. But until then, it's been a pleasure. We really love the question. It takes us down roads we couldn't even imagine we were going to go down. So we really appreciate you guys joining us. And thanks. We'll see you again in 2 weeks.